Hello everyone, very good evening to all of you. How are you all? I hope every one of you is doing absolutely fantastic. Let me check if I'm yes, I'm pretty much audible. So guys, in our continuity series of this triple R series, where the first chapter I came up with electrochemistry. So we are right now starting from 12th standard, and let me again reveal what we are trying to bring over here on this channel. So these sessions are typically all dedicated to the JEE 2025 student who are gonna to appear in their upcoming shift and for their advanced. In this series, what we are bringing is, this is your triple R series where we are gonna to cover all the chapters once again with a proper set of practice. In this session, I have come up with a very beautiful journey for two chapters which are quite small chapters from 12th standard physical chemistry. These are your solutions and chemical kinetics. So I will provide you complete explanation, complete formulation, and some sort of question to practice there. And then there will be some expected 50 very important question that may come in your exam and also may or may not. But most importantly, you can crack and you can apply your proper practice and can ask me all the doubts in my special session that is gonna to happen on Unacademy application. So guys, be aware and just go and enroll yourself. The link will be provided in our description itself. Maybe after the class I'll create the class and then I'll provide the link. Please go through that link. I'll also pin that link in the comment section also. For that link you can enroll yourself for practicing and doubt resolving session, which is gonna to happen tomorrow 11 o'clock probably. Let's start it. So we have two chapters with us. We have chemical kinetics from 12th standard and solutions from 12th standard. Another physical chemistry chapter from 12th standard was electrochemistry that I have covered in our previous session. So those who are new do not know who am I. Guys, my name is Sanjay Arya. I am passed out from IITSM Dhanbad and have been teaching from past 10 years, and I have mentored over 5 lakh students online and offline, and it's like a journey that I have already traveled. I want to convey the same path to all of you, so stay tuned with me. Those who haven't subscribed to our channel, please subscribe and just stay updated for all the lectures you want. We'll keep on bringing the sessions for you. So let's start the session from chemical kinetics. These are the set of topics which are highly important, and that basically completes our whole chapter. In this way, the rate of reaction, rate law, order of reaction, then we have some sort of zero order, first order, pseudo order, and mechanism of the reaction, molecularity, factor affecting the rate of reaction, Arrhenius equations, and then collision theory. That's what this chapter is whole made up of. The first topic of this chapter is the chemical kinetics. What is the meaning of chemical kinetics? So basically, chemical kinetics means the study of a reaction, by what speed the reaction is carried on, when can this reaction get over, and also what are the factors that can impact the speed or the rate of the reaction. So this is what we call as the chemical kinetics. The correct answer should be the chemical kinetics is a study of feasibility, whether reaction may happen or not, because that is also decided. Let's suppose the reaction is happening with a almost zero speed and not even happening, or this can be considered as a non-feasible reaction, and an extent to which the reaction has been completed also can be determined using this chemical kinetics. Speed of the reaction, I guess all the options are correct in this question. Just an introduction of the chemical kinetics from a question. Next thing is rate of the reaction. Okay, do you know what is the meaning of rate of a reaction? How fast a reaction is happening? So that can be determined using the in the terms of how the molar concentration of reactant product is changing. Okay, molar concentration, whether if the reaction is happening in the terms of gases and all the reactant product species are gases, then you can use pressure over there. So there are like plenty of things what keeps on changing. So let me just define it. It's a rate of change of concentration with the time of a different chemical species taking place in this part. So let us suppose very simply, if I write an equation that R is converted to P, where R are the reactant, P is the product. For this particular equation, the rate of reaction can be written down as, we all know that the concentration, okay, the concentration of reactant keeps on decreasing and the concentration of product keeps on increasing. So this becomes negative. Okay, there are also two ways to identify the rate of reaction. The one of them is called as an average rate of reaction. So average rate of reaction is defined for a particular time interval. So let us suppose from t is equals to 0 to t time we are finding it out. So for that duration, the average rate can be written down as negative of delta of the concentration of reactant divided by delta of t, where t is representing the time here, and it is also equals to the positive of delta of product divided by delta t. And all you know, this in the square bracket whatever we are writing is the molar concentration. That's called as the average. Okay, don't get confused, very simple terms are there. We also have an instantaneous rate of reaction. So the instantaneous rate of reaction will be equals to negative of d by dt, dr by dt, or it can be positive of dp by dt. So this is how we can represent the rate of a reaction, average versus instantaneous. Instantaneous means at a particular time. So at a particular time, you can also take a slope of the graph if the graph is between concentration and time. Okay, let me give you an idea. So let's suppose we are talking now about, we are having two graphs here, just to show you what is the meaning of average and instantaneous. So we'll take a question directly. I guess that will be more fruitful. So there is a question given to us, everyone, and we got to identify the average rate and instantaneous rate of formation of the product at t equals to 20. So t is equals to 20 is the time given to us, so that's an instantaneous rate, and from 0 to 20 if we calculate it will become an average rate. There's a, what is this by the way? Okay, which graph, concentration versus time, which graph does it show like this? So it's keep on increasing. So we know that reactants are maximum at t equals to 0. And then the concentration of reactant keeps on decreasing. Talking about products, their concentration keeps on increasing with the time, because products are 0 at the start of a reaction where only reactants are present. So when the time spends, the products are forming, reaching to some saturation level. So this is the 20-second given to us. So I'll first of all find out average rate. We'll first of all try to find out what average rate. We all know how the average rate is formed out. We have to basically find out the change in concentration upon change in time. So what's the concentration change by the way? We started from here, which is I guess 0 I think, and from 0 to we reach to, sorry, 0 to 15 we reach. So this is like delta of concentration of product upon delta of t, which is also equals to P2 minus P1 by T2 minus T1. So what is P2? Concentration of product at T is equals to 20 second is 15 molar minus 0 divided by 20 second minus 0. So this is your, what is this? 3 by 4, 0.75 mole liter inverse second inverse. Okay, considering the molarity as a measuring parameter. So that's how we find out the average rate. This is the average rate. Now instantaneously we have to find out, okay, if we have to find out over here, you know what, over here. So guys, at let's say we have to find out instantaneous rate of the reaction, and time is being given to us at 20 seconds. So how do we find it? So we'll basically, this is nothing but the slope of the graph, and since it's a increasing graph, it will be like positive of dp by dt, which is nothing but the slope of the curve. And the slope of the curve can also be identified using this theta. We have to find out this tan theta is actually the slope. So tan theta, how do you identify the tan theta here? So if this is a theta, this also be a theta, and for this theta the tangent will be, what is tangent by the way? Perpendicular by the base. So perpendicular is what? This is the perpendicular for this triangle. So 15 minus 5 divided, and we'll keep it positive. Rate has always been taken as positive upon the time taken is what? This is the time taken, 0 to 20. So this is 20 minus 0. So 10 by 20. So this will be 0.5 molar second inverse. So can you correct? Can you identify the correct answer? 0.75 and 0.5. I think B is correct. Did anyone solve this question, everyone? This was a beautiful question where we are not just getting the concept, we are also getting how to use that concept. Okay, so it's a perfect question we got. It's a mixed up of the concepts, and that's it. Now the next thing that comes in this chapter is the writing expression of the rate of reaction. And I remember one of the question like this came in your recent exam 2025 JEE Main first attempt, probably in our coming shifts or in our tomorrow's discussion session and the doubt discussing session, practice session. I'll bring those questions also. Okay, so you will I'll let you know about those questions. Anyways, now we have it's simple reaction like AA, BB, CC, DD. So guys, whenever these stoichiometries are different, every single species keeps on decreasing or increasing by different extent. Okay, different extent, because the stoichiometry is difficult. Because sometimes we write like N2 plus 3H2 gives 2NH3. So 1 mole of nitrogen is combined with 3 moles of hydrogen. So definitely the rate of decomposition of hydrogen is 3 times, like 3 moles of that will be reduced. So using that only will identify how to determine that all the ratios. So I would like to give you one simple suggestion, that just simply learn this equation. You got to divide it by the stoichiometry, and that is what the rate of this reaction suggests to us. That rate of reaction will be equals to negative of dA by dt upon its stoichiometry. Negative, why am I putting a negative sign? Because these are reactant. For negative we put a negative sign to make overall rate as positive. So dB by dt, dC by dt, dd by dt upon their stoichiometry. So this will be equal. Okay, so that's how we basically use it. So let me give you another example here. So let's say an example is there, N2 plus 3H2 produces 2 times of NH3. It's a balanced chemical equation. This process is called as Haber's process of the manufacturing of ammonia. And in this process, I'll let you know what is the rate of reaction and how the rate of reaction varies. So first of all, wherever you find 1 as a coefficient, as a stoichiometric coefficient, that species is actually representing the rate of reaction. So the rate of the reaction will be negative of d of N2 by dt. This is also equals to the positive of, sorry, it's also negative because it's a reactant. So because the change what we are writing over here comes in negative for reactant, so that negative multiplied by the negative side sign outside will become a positive one, and rate is always taken as positive. Then it will become dH2 by dt. So can you see that rate of decomposition of hydrogen is 3 times of the dN2 by dt, because it will be cross multiply, 3 comes here. So rate of decomposition of nitrogen is 1/3 of hydrogen, and hydrogen is 3 times of the nitrogen. Why? Because 1 mole of nitrogen is combined with 3 moles of hydrogen. So more hydrogen is consumed more than nitrogen, and that will be kept as positive 1/2 dNH2 by dNH3 by dt. So that's how we find the correct relation between all of them. Now you apply the same formula, same concept, and find out the correct answer for this question that was actually asked in JEE 2024, I guess. I don't remember it, but we'll come to some PYQs also, but try to solve this question at least once. There is a question given to us. We have no clue what is this question all about, and for that the rate expression has been given like this. We have to identify the correct equation, the correct chemical equation for which we can write the rate of reactions like this. So how can we do it? It's very simple. Okay, we got to keep this thing in our mind that wherever you find negative sign, those species will be the reactant. So try to identify where are the reactants. This is the reactant, this is the reactant. So where are the reactants? B is a reactant with nothing is here as a like in division. So it's simply B, plus D is also there, and 1/3 is there. So definitely the stoichiometry might have been D. With a negative sign they were there, and that's why I have taken them as a reactant. Product will be having a positive sign. So positive is given with C, so it will be like 2 times of C and 4 times of A. Can I find such equation? Can I find such equation? I guess B is correct. B is absolutely correct. So guys, keep on practicing the questions with me, and that will literally give you the confidence how the question asked in the on over these topics and how to respond to these questions. Because see, it's been a whole year, and now by this time you all are very much aware about the topics, their continuity, their sequences, and every time you start studying you read out 2 or 3 pages and you reach to nowhere. Sometimes this happens to most of the students. What I want to suggest you is manage some time with me. try to sit in my exam, in my ongoing lecture, and take your time, complete your lecture, and solve all the question what I'm trying to explain over here. I will also give you what formula is there, how to apply. Formula application, either eventually you'll become confident and you can start solving some PYQs which have been asked previously in 3-4 years, not beyond. Don't go too far. And also some of the questions from 2025 itself. And don't forget to attend my tomorrow's lecture that is actually based on the practice and the doubt session part. Okay. So now we'll take you to the next question, one which is very similar question to this, that nitrogen dioxide required for the reaction is produced by the decomposition of N2O5 and CCl4, and the reaction is given like this. Initial rate of concentration of N2O5 is 3 and it is 2.75 after 30 minutes. So the rate of formation of NO2 will be what? It's a very easy question, by the way, but I have a very, simpler approach about this question, that initially was this. So what, first of all, I like to find out that what is delta of N2O5 upon delta T for a time y, which is called as the rate of disintegration or rate of decomposition of N2O5. So this will be equals to how much? Change in the concentration. So with the negative sign, final minus initial. Finally, it is 2.75. Initially, it is 3. So that's why I'm saying that it keeps on decreasing. The change will come up as negative. The negative change multiplied by negative sign will become positive upon time. And how many time second? 30 minutes. So 30 minus 0 is the time. So how much does it come? It's 0.25. So 25 by 30, 10 to the power minus 2. And you can also write it like 5 by 6. Okay. The rate of formation of NO2, but let us see how rate of formation of NO2 and rate of disintegration of N2O5 are connected. So we'll do one thing. The negative sign with delta of N2O5 by delta T is also equals to the positive of 1 by 2. We also need to put the coefficients because the rate of reactions are equal, the rate of complete reactions are equal, and rate of decomposition of N2O5 and formation of N2O T might differ. So this will become 1 by 4 times of delta of NO2 by delta T. That's the equation that we have to find out. So delta of the rate of formation of nitrogen dioxide in this interval will be how much? This equation, which is half of 5 by 6 10 to the power minus 2 into 4. So that's how it entirely look like. So it's 10.10 by 6 into 10 to the power minus 2 molar minute inverse. This is in minute inverse. Try to find out the correct answer. So 10 by 6 is, I think, 1.67 10 to minus 2. I think B is correct. Right, guys? B is absolutely correct answer. And this question was like, this question appeared in 2024 JEE Main examination. Okay, we'll bring that strategy session, don't worry, SP. Okay, we'll discuss it today and then we'll make a plan on this. Now come to this next topic called as law of mass action. Okay, so you know what is the law of mass action? It's just a relationship. It's just a relationship between the rate of reaction and the reactants given in the equation. So whenever for a reaction, there could be two types of reaction. One of them is called as simple reaction or one-step reaction. Another one is called as complicated or multiple-step reaction. So for a simple reaction, it's very easy that rate of the reaction is directly proportional to the concentration of the reactant raised to its power of stoichiometry. Whatever the chemical balanced reaction is there, that stoichiometry goes in the power. So let us suppose this is the complete equation which is given to us. So what does it say? That for A1, A2, A3 reactant, the rate of reaction will be directly proportional to the concentration of these raised to their power of stoichiometry. So stoichiometry is used when the reaction is given to you as a simple reaction, but whenever a complex reaction is there which takes place in more than one step, for that you cannot use directly the stoichiometry. It may or may not be equal to stoichiometry, so it's not right to comment there as a stoichiometry. Okay, so that's why in this expression you are not seeing P, Q and R, instead you are seeing X, Y and Z. So X, Y and Z may or may not be equal to P, Q and R depending upon the nature of reaction. If the reaction is a single step reaction, then P, Q, R will be equal to X, Y and Z respectively. If this is a complex reaction, then they will not be equal to or may be equal to. That we have to find out. So we'll come to that. This is called as the order of reaction. So anyways, taking you to the another example that so let us suppose any reaction is given to you. Let's say this is AA. No, it's fine. So where were we? So this is called as the rate law. So what is the meaning of rate law? An expression that contains the concentration of reactants with some power. The sum of the whole power is called as order of reaction. So what if you ask me, so tell us the order of reaction. What is the overall order of this reaction? The order of reaction with respect to A1 is X, with A2 is Y, and with A3 is Z. And overall order of reaction will become X plus Y plus Z. So this will become X plus Y plus Z. This is the order of reaction. Correct? Then comes unit. So first of all, I'll let you know what is rate constant. So whenever we say that rate is directly proportional to the concentration of reactant raised to their order, there is a power which is also called as order. So when rate will be equals to something, that proportionality constant is called as the rate constant. So R is directly proportional to there, and then K becomes the rate constant. So K is defined as the also defined as the rate of the reaction when the each and every species has a unity as its concentration. So concentration becomes 1, then K will become equals to A, like that. So this was written, rate is written as K into some, let's say A1 raised to power X, A2 raised to power Y, and so on. So let's say this all has become 1, then R will equals to K if all the concentration of A1, A2 all becomes equals to 1. You can also identify the unit of K. So rather than writing whole different units of K with different order of reaction, I'll directly give you a way that mole per liter is actually the concentration part. You check it out. So this is rate is what? If I ask you what is the unit of rate, rate is actually mole liter inverse second inverse. And what is this? This is whole mole liter inverse raised to the power of n. N is the order of reaction. So if you solve it, you will get mole liter inverse raised to power 1 minus n into time inverse. This is the rate, this is the unit of rate constant, and you can apply any values out of it. The given one are over here, and you can find out the respective value. Okay, I think we should start solving one question on it, and then we'll become more comfortable on it. I remember a question in JEE Advanced in 2014. Okay, 2014 JEE Advanced paper 2. This question was asked, and believe me, you will be able to solve this question very easily. Believe me. How? Let's see it. So the elementary reaction. You know what is the meaning of elementary reaction? All the reaction that occurs in just single step. So it's an elementary reaction. M to N we are reaching. The rate of disappearance of M increases by the factor of 8. First of all, let me write this thing. That rate will be directly proportional to the concentration of M and raised to its power of n, which is called as the order of reaction. Right? This is the order of reaction. So let us suppose this is R2 by R1 will be equals to K will be cancelled out. Simply M 2 raised to power n upon 1 raised to power n. So what is this R2? It says that it on doubling it reaches to 8. Okay, this is equals to 8 is equals to, this is actually 2m upon m raised to the power n. So guys, what is the value of n? What power of 2 will give you 8? I think n should be equals to 3. So the order of reaction is how much? 3. Now this is an advanced level question. Do you think it's an advanced level question? I don't think so. It's a very easy question, by the way. It's very easy question that we can see, and that question came in one advanced, and that is based upon highly easy and very simple topic that we are right now dealing with. Very easy topic. Okay, very elementary question, in fact, I must say. Another question came in JEE Main 2024 to find out the order of reaction. So what we have to do in order to solve these questions, I'll give you a way. whenever some datas are given related to the concentrations and rate, so try to frame a reaction like this. Try to frame it that rate is equals to, okay, so why aren't we taking directly order as 2? Why? Because sir, this might not be an elementary reaction. It can be a complex reaction that will become will be getting a incorrect answer from here if we directly pick 2 as the answer. So we'll try to first of all formulate it in this way, that K into concentration of HI raised to the power 2, right? So this is the general equation now. Now using the general equation, we have different values at different points, and we can identify the value whatever we want. So let us suppose we will pick these two values, and I'll try to divide them with each other. The rate at this time, let us suppose 3 into 10 to the power minus 3 divided by 7.5 into 10 to the power minus 4 must be equals to, so K and K will be cancelled out, and this will be concentration of HI is 0.01 raised to the power n divided by K into 0.005 raised to the power n. So now using that equation, what you can find is number of value of n. So please find it out and allow me a moment. I'll come back with water. Okay, just a few minutes, just a 1 minute. Okay, I'll come back. So yeah guys, I'm back. So did you try to solve this question and try to find out what's the correct answer? This question also came in JEE Main 2024. Question appeared in JEE Main 2024. Okay, let me reveal the correct answer. So the answer will be, I think, this is 2. This is also written 4. 0.75. This will be equals to 2 actually. Okay, 2 is correct. So now, as I was discussing with you that what are the type of reactions for which we are about to find out the order and considering the rate of reactions and their rate laws and all. So there could be 2 type of reactions. One of them is called as elementary, that happens in single step, and another one is called as complicated reactions, complex reactions, or we also call them multi-step reactions. So this is complex reaction, this is elementary reaction. So elementary reaction is the one that occurs in the single step, and that's why it's very easy to find out the order of the reaction. How? AA plus BB gives you product. So the rate of the reaction will become what? Constant multiplied by A raised to power its stoichiometry, B raised to power its stoichiometry, because stoichiometry itself will be the order. So okay, remember this part, that whenever you are given with an elementary reaction, the stoichiometry itself will be taken as the order of reaction. Okay, that's it. But now if we are given up with a complex reaction, that how are we gonna to find out the order of reaction? For that, these steps are gonna to be followed. Okay, and there's no need of basically rote learning down these all steps and writing down. I'll give you the idea and we'll move forward then. So what you can do is, I'll give you an idea, and while practicing you can do questions by your own. There we can reach. This is the step given to us, and I'll explain that step. Let us suppose something is given up like this. So what do we see? That rate of the reaction will be equals to what? K multiplied by what we have slow step. Okay, do you know what is a slow step? Slow step is also called as rate determining step, RDS. Why am I saying this? It's like, what if I give you 1 lakh rupee and 1 rupee? So what you are mainly concerned about, 1 lakh or 1? Definitely 1 lakh, because 1 lakh is way bigger than 1 rupee. That is exactly what happens in the rate of reactions. Let us suppose the fast step takes place in 10 to the power minus 4 seconds. Very simply, like you blink it and it happens. And let us suppose the slow step takes place in 1 second. So it's 1 plus 0.0001 reaction seconds. So it will become almost equal to 1 second only. And that's what I meant to say, that the RDS, rate determining step, will be the slowest step of the reaction. And the one which we are right now doing is called as the study of the reaction, and it's also called as the mechanism, like by what steps the reaction is exactly proceeding. So we found out RDS first of all, and then we'll apply from the RDS itself. What we are trying to do is, we'll directly apply the rate law. We'll simply apply the rate law. R is equals to NO 2Cl raised to power 1 and Cl raised to power NO 2Cl raised to, this is not a good question here. Sorry guys, not a good question. So this will be directly raised to the power 1 given to us. Then you have to check whether the given reaction has any intermediate, but no, there is no intermediate. It's only this. So the correct order will be, maza nahi aaya yaar. Correct order will be 1 here. I think this is a better question. Came in JEE Main 2024. I think this is a better question. Let me solve this question and then we'll see how these questions are done. The slowest step, which is also called as the rate determining step, RDS, rate determining step, we have to first of all apply the overall rate of reaction. Overall order of the reaction will be what? The overall order of the reaction is what? So for this, RDS has to be applied with its rate law. So apply the rate law, that rate of the reaction will be equals to constant multiplied by NOBr2 into nitric oxide and raised to power 11, which has been given in the slowest step as well. But what we see is, we have to cross check whether any of the species given in the rate law is not in the main equation. This is the main equation, and I found that NOBr2 is not in the main equation. That's why this is a reaction intermediate. This is a reaction intermediate. Like this was somewhere formed in the reaction, then it got eventually basically exhausted out, and then final products were made. So this is also called as that incorrect rate law. We can call this thing as incorrect rate law. Why is it incorrect rate law? Because the rate law must not contain any reaction intermediate. What are the species there must be present in the main equation. This is called as the main equation. In the main equation, everything whatever written over there should belong. If not, then we have to change it. We have to substitute it. How are we going to do it? Now we'll use the Faster equation. Within Faster equation, we can define K equilibrium will be equal to, let's say Kc, I'm talking about Kc. So Kc will be concentration of NoBr2 divided by concentration of NO into Br2. This gives you the concentration of NoBr2 is equals to Kc multiplied by concentration of nitric oxide into bromine. Now you can substitute this value over there and you will be finding out the final rate of reaction becomes K into. So this is NO, K into Kc, K into Kc into this NoBr2 will be NO, so NO raised to power 2 into Br2. So then that's how we got. This will become K dash, and this is the final order of reaction. The overall order of reaction is, what was the question? Overall order. Order of the reaction will become what? 2 plus 1 is equal to 3. 3 is the correct answer. So that's how we identify the order of reaction, and using some certain steps and using some basic values and basic mechanism. If not, let's say something is not given equilibrium, we'll assume it in equilibrium. Okay, some faster steps can be assumed in equilibrium, and then the final order will be revealed. So that's how we approach to these questions. Now comes the another topic. So till now what I was discussing is called as an order of the reaction, and right after order we have to discuss about molecularity, which is again very simpler concept. Okay, molecularity. How do we define molecularity? So molecularity is the number of molecules which are participating. The number of molecules which are participating in the reaction to give you the product. So for an elementary reaction, it's very easy. You can count down the number of reactants. You can sum the stoichiometry, and that will become the order and molecularity. So order and molecularity are the same for an elementary reaction. But for a complex reaction, there is no point of writing down the molecularity, because in complex reaction, there are several steps involved. Every single step has different molecularity. So that's why for a complicated reaction, complex reaction, we can't say about molecularity. It's very illogical to talk about molecularity, and even if it is asked for RDS, then we can tell for RDS specifically, but again every individual step has a different molecularity. So it's simple that for an elementary reaction the molecularity is equals to the order itself, and for complex reactions the molecularity will not be defined. That's what it is written over here. Okay, molecularity can be 1, can be 2. Mostly it is 2, sometimes it is 1, and rarely it is 3, but beyond that it's not possible. Beyond that doesn't go like that, okay, because like 3 directions, 3 molecules are completely coming to each other, colliding to each other. This concept also would be taken from the collision theory, so that for a reaction to happen, reactant molecules should come too close to each other and they must collide. So this collision will not work beyond 3, mutual collision, okay. So see, unimolecular reaction, molecularity is 1, bimolecular reaction, molecularity is 2, trimolecular means molecularity is 3. Let's see a question here. Guys, please see this question, look at the question and try to respond. Which of the following statement is wrong? Law of mass action and rate law expressions are the same for a single step reaction, which is absolutely true. Both order and reactions on molecularity normally a maximum value of 3. Both order and of reaction molecularity normally has a maximum value of truth, which is also true. Order of reaction and molecularity for an elementary reaction are the same, which is also true. We just discussed. And molecularity of a complex reaction, if it is a complex reaction, you cannot define the molecularity. This is the incorrect one. D is the correct answer, false. And the incorrect was asked, I guess, no? Wrong. Concept of order, molecularity. Okay, so let me just quickly recap. Rate of the reaction, how to write down the rate of reaction, average rate of reaction, instantaneous rate of reaction, and expression of rate of reaction. Then rate law, Then for rate law, we went for order of reaction, molecularity of reaction, and then now we have reached to some of the very important reactions on zero order reaction. So please take an example first of all. That photochemical reactions that happens in the presence of sunlight are the example of zero order reaction. Enzyme catalysis reactions, these are also zero order reaction. Dissociation of gases on the solid metallic surfaces are also examples of zero order reaction. These are the examples, and not necessarily to be remembered, because question doesn't come in this way that what order of this reaction is. It may come on the application based type question, where the reaction mechanism was given and it's a complicated reaction, and then it has been asked that what will be the order of reaction, that we have done earlier for a question. So anyways, that was all examples included with first order reaction. You know what first order reactions are there, guys? All the SN1 reaction, all the E1 reaction, etc. These all are the example of what? First order reaction. ARSN1 reaction, and even all the artificial and natural radioactive decays are also the example of, they all follow first order reaction kinetics, first order kinetics, and these are another examples. So for all of these, you got to remember a few things that I want to express it, but I don't want to waste the time. I want you people to learn about all zero order, first order, second order, and nth order. For all four, you must know their integrated rate law. What is the meaning of integrated rate law? Let me take you an example and then I'll explain it. So first of all, I'm taking this example for a zeroth order reaction. Let's say for a zero order reaction. Let us suppose a reaction is given to us which is a zero order reaction. If any reaction is a zero order reaction, then how can we write down its rate law? So rate will be equals to, so let us suppose first of all this reaction be simply R is going to P. Let us suppose at T is equals to 0 time it is A naught, it is 0. At T is equals to T time it has become A naught minus X, and this will become X. How do you write the rate law? The rate of the reaction will be equals to negative of D of A naught minus X is equals to dx, the same thing, by dt, of course by dt, which is also equals to rate constant into concentration of reactant raised to the power 0. So this will become R is equals to K. That simple. So I'll write an expression that dx by dt is equals to K. So D, okay, this is also A naught minus A is equals to what? A at T time. So this has become what? Dx is equals to K dt. And now there is a differential equation. This is the part which is called as the differential rate law. This is called as the differential rate law, and what we are deriving is integrated rate law. So dx is equals to k dt. On solving, you will be getting integrated from 0 to x, integrated from 0 to t time. So x is equals to what? Kt. What is this x? X is actually A naught minus At is equals to Kt, and you can also say that At is equals to A naught minus Kt. So y is equals to mx minus, so c minus mx graph is there, straight line graph is there. And this expression what we have derived it is called as the integrated rate law. Differential rate law versus integrated rate law. That is what we call it as a integrated rate law. So also there is one more thing which is very important, called as the half-life of the reaction. What is the meaning of half-life? The half-life meaning in what time the original reactants are converted to half of that, or let's say half of them is consumed, half of them is remaining. So what we see that at the rate half-life, which is also written as T half or T 50%, at the rate half-life, the concentration of reactant AT will become equals to the A naught by 2, and time itself becomes T half. Then the expression of AT is equals to A naught minus KT will also be becoming A naught by 2 is equals to A naught minus K into T half. If you solve this equation, your T half will come up as A naught by 2K. So anyways, what I'm trying to explain is this is how you can derive it for first order, zeroth order, second order, but don't derive it. The reason behind is because the derivations won't be asked in your exam. The only thing that has been asked is their direct integrated law and applications of those expressions, giving you some values, finding some values on different time period or different k, different rates, and something can be asked like that. So I'll take you first of all to all the order reactions, all the expressions, their integrated law, and along with their half-lives. So do learn it. There are plenty of things we use. For first order, zeroth order we just have discussed. For first order, or you can also use that time is equals to 2.303 by k logarithm of a naught by 80. This can also be used. This is the integrated rate law, and half-life will be 0.693 by k, or it can also be written as ln of 2 by k. Okay, using this only I have derived it, ln 2 by k. That's what we have. First order reaction with you. The rate laws for first order reaction we have. Right after the first order reaction and its rate law, we have second order. So for second order, the expression is quite simple, and it is 1 by a t minus 1 by a naught is equals to kt. K is the rate constant for second order reaction, and also its half-life will also be equals to 1 by k into a naught. Then for nth order reaction, if you can remember, it's fine. If you can't remember it, no problem. So the expression is quite simple, that 1 upon a minus x raised to power, this is also called as at. So I'll simply write it 1 by at raised to power n minus 1 minus 1 by a naught raised to power n minus 1 is equals to n minus 1 into kt. So that's an expression that you have to use, and it's half-life. Always remember, I don't remember this whole formula of half-life. T half is equals to n minus 1, 2 to the power 2, n minus 1 minus 1. I don't know, but you can simply say that T half of a reaction, because this formula will be highly useful in order to identify the order of reaction. If some different half-lives have been given, you have been given with some different half-lives on different extent of initial concentration you took. So you got to identify, you got to find out the order of reaction somewhere in the question. Then what you have to do is make 2-3 expressions like this, that T half is directly proportional to the a naught raised to power 1 minus n. That's a very important formula I'm writing down on the screen, that it is directly proportional to the a naught raised to power 1 minus n. Now you can use two different half-lives. You can use two different concentration given, and using that 1 minus n can be found out using this formula. So just have a look on this, and then we'll start solving some of the problems on the given expression. Okay, so until here it's done. Now we'll try solving some questions, and let's see how the questions are done. The question is quite simple. It's a zeroth order reaction, first of all. For a zero order reaction, we know it's integrated rate law. We can identify whatever it is needed. Half-life of this reaction is 50 minutes. Then the time taken to reduce to 1/4 value, okay, will be what? So anyways, what we can do is we can simply calculate the either initial concentration using it. What we can find out? I think we can find out the value of K from here. So what will be the value of K? A to B is zero order reaction, the half-life of the reaction. So you know what is the meaning of half-life reaction? So T half for a zero order reaction we found it was equals to A naught by 2K. A naught by 2K, okay. So let's suppose the initial concentration is 1 molar. Let us suppose it, okay. So in that way, the value of K will become how much? 2 times of T half, which is 50. So this is coming as like 100. Okay. $100 and unit will be what? This is second and second inverse, molar second inverse only. This value of K we have got. Now you apply the same thing that it is being converted to 1/4. So T 1/4 will be equals to where the reactant is being converted to 1/4. So it is like you remember that part that AT is equals to A naught minus KT. So if you apply T is T14. So what will be the value of AT remaining? Remaining one will be if reduced to 1/4. It is reduced to 1/4 now. So it will become A naught by K, which is, let's say 1 molar was initially taken. So 1/4 is equals to, this is 1 minus K is already known to us, 100 into T of 1/4. So T is actually what? 1/4. Like this you have to write down. So T 1/4 will be coming up as 1 minus 1/4 is 3/4. 3/400. Okay. This will be, I don't know what have I done, but hopefully it is going correct. So K will be equals to, okay, there we had an incorrect answer. K will be equals to 1/100 and molar second or minute inverse, molar minute inverse. Now you will apply the same thing over here. 1/100 will be here. So T1/4 will be equals to 3/4 into 100. Now I think 75 minute will come as the correct answer. C is the correct answer. That came in 2023. That simple question came in 2023. There we have the another question from again JEE Main 2023. An organic compound undergoes first order decomposition, and if the time taken for the 60% decomposition is 540, the required for 90% will be what? So okay, we will find out K first of all. So K is what? I told you 2.303 by time taken for this is 540, 60% logarithm. So this is A naught divided by, after 60% something completion, how much will be remaining? 40%. So this is 0.4 A naught. 0.4 A naught. Okay, this is like 4/10 actually. So we have got the value of K here, which is 2.303 by 540 and logarithm of 10/4, or we can simply write it 5/2. This is equation number 1. Now simply using that equation we can find out the time for 90% decomposition. So for 90% completion it will become what? 2.303. So this is like interconvertible. Okay, you can send T here, K here, it's cross multiplicable. 2.33 by K, value of K you already have got it, 2.303 into 50 into, okay, I'll first write it over here, 2.303 by 540 and logarithm of 10/5, 5/2. Into logarithm of after 90% completion, this will be A naught upon 90, 10% will be remaining. 10% is 0.1 A naught. Overall, this value is 10. Log 10 is equals to 1. So let leave it. We'll simply write that T 90% will be equals to what? 2.333 is cancelled out. 543 divided by log 5 by 2. What is log? Log 5 minus log 2. Log 5 is 0.77. Log 2 is 0.3. So it's 540 0.47. That is the correct answer. So like double of this will be coming up as, I guess, 1350 could be the correct answer. 1350 is correct, guys, and that is also in minute. Oh, sorry, second. Second is, it is given in second. It's quite an easy question, but yes, what we need is a proper set of concept behind it, proper set of explanation behind it. That's it. So a good question we had, JEE Main 2023. Now the next thing is, the next question, I think this question was appeared in one of the advanced question, as the column kind of question is here. So some graphical representation is there, but we don't need to worry about anything, because we all know what half-life is directly proportional to what that is proportional to. So that's how it works. And we know that if we talk about the T half is directly proportional to the concentration of A naught raised to the power 1 minus n. So ln of A, this is for first order. Where do you see first order reaction? We have first order over here. With respect to A, we also have ln of A first order. So R can also satisfy fourth. P can also satisfy fourth option. Now talking about Q. Okay, concentration versus time. What graph will be there? Concentration versus time. The concentration of reactant keeps on decreasing. But how? That we have to find out. So A is equals to the power 1 and T half. So this is like what is T half for zeroth order? You know, for a zero order reaction, the half-life can be given up as A naught by 2K. So it is directly proportional to A naught. So T half or A is directly proportional here. This is for zero order reaction, where you can see zero reaction, I think S. So S has second option. So S has second option. I think S is second option is only one option here. A is the correct answer. So P belongs to 4. Q belongs to 1. Okay. Q belongs to concentration of A versus time. So it's a general reaction, by the way. This is for everyone. This is for generic. Concentration versus time keeps on decreasing like this only for reactant actually. The correct answer is A. A is correct. Another question on the similar concept. Okay. Sir, will you teach all? Of course, we will cover all the chapters, buddy. We will try to cover all the chapters, and that is why, since we do not have plenty of time with us, just a 2 months duration is there with us for your JEE Main second attempt, and that what it made us to bring two chapters at once. Like today, we'll try to cover 2 chapters, chemical kinetics as well as solution, and not just chapter, proper practicing, proper doubt discussion, and your discussion session, doubt discussion session, and 50 question expected questions, and their practice session will be conducted tomorrow. So tomorrow 10 o'clock or probably by 11 o'clock we'll basically create a session. and the link will be provided in the description itself, but not right now. I have not created the class right now, but it will be provided within the this description only, and I'll pin in the comment also. So please do enrollment, and you can come to the tomorrow's doubt session as well. A question came in 2023 that A to B is a zero duration, half of the duration is 50 minutes. We have already completed this thing, and 75 will be the answer. This question has been already done. There is a question came in JEE Advanced 2013. Now that's a good question actually, and the simply says the time taken for 75% duration is twice of the time taken for 50%. So I know that the correct answer should be D, first order. Why? Because there's a thing I want to let you know how the variation goes on with first order reaction. So for a first order reaction, if a reaction is a first order reaction, then let us suppose initially it is given as A naught. So when the time passes T half, it becomes A naught by 2 for everything. For next T half, it will become A naught by 4, half of this. Then at next T half, it will become A naught by 8, and so on. This happens for first order reaction. But what about the zeroth order reaction? So for a zeroth order reaction, let us suppose we are being given up with some initial concentration of 100. Some T time has been taken. In T time it has reached to 95. Again same time has been taken, same amount will be required. So this will become 90. Another T, it will become 85, 80, and so on. And similarly, if you started from 1000, because it is independent of the initial concentration you are taking. So on the T time, what it will be becoming? It will again 995, 990. In the same time, it will become 985 and 980, and so on. So this is actually how first order and zeroth order reactions move alike. So please guys consider this thing, and just take these things in your mind, because this is helpful in direct identification of this question. Otherwise it will take too much of your time. So now what's going on is, first of all we'll discuss about this thing from basics only we'll go. So this is P and Q are given to us. Let us suppose this is a reaction, and the overall order has been asked. So let us suppose the rate is equals to K into P to the power X and Q to the power Y. So first of all, let us check it out. For Q, what we are checking out is, this is Q, the concentration of Q is equals to Q naught minus KT. This kind of graph is there. Y is equals to C minus MX. And this is actually for zeroth order reaction. So for zeroth order reaction, the graph is given like this only. We know about this reaction. So Q has a 0. So that's why what? Y is equals to 0. And one more thing, 75%. So since something is A, then in half life it has reached to A by 2. Then in 75% it will reach to A by 4. So since T half is exactly T half into 2 is equals to T1 by 4. This is called as the first order reaction. So if it's a first order reaction, then X will be also equals to, that's why X is equals to 1 and Y is equals to 0. X plus Y is the total order of reaction. X plus Y will come, what is 1 plus 0 as 1. Correct answer is D. Simply you can do it. Try this question by your own first of all. So guys, I'll take you to the next topic from here. So this, what we are right now seeing, is actually the first order reaction in terms of partial pressure. How do you apply in the terms of partial pressure? So there's an equation given like this: A, 2, B, C. It would be D also. Don't you just get confused with how many terms are given. And that's why I've written a note that do not learn down this equation. Every time you have to apply it freshly only. You know, how am I saying it? Because sometimes it could be B, C, D also. Sometimes it could be 2A plus B. But you won't face the same thing everywhere. And that's where we have to find out in terms of pressure. Okay. Let's take one question as an example, which was asked in JEE Main 2023. A question that already came in JEE Main 2023. I'll explain this question and I'll make sure that you people understand it very well. What has been given to us, that we have A, everything is gaseous, no need to write down the gas, everything is gas. So the initial pressure of the system was found to be 800. So when time was 0, this was 800 mmHg, because it is all because of A. That's why the pressure was, let's say, this. Then eventually, and they were 0, 0, they were imparting to the total pressure as 0. The reaction started to happen at a time T1. Some of the reactant got consumed. So let us suppose X pressure was reduced from the reactant side, because some X number of moles were, let's say some number of moles were reduced. X pressure is consumed. So whatever the number of moles are formed there, exactly the same number of moles will having the pressure directly proportional to the X. So let's say this is reduced by X, then it will be produced by 2X, this will be produced by X. Actually, I'm treating the equation as pressure is directly proportional to the number of moles of the gases. Like that we have to work upon. So okay, let's find out. So what is happening? So what is it saying actually? There's one more thing is saying that T is equals to T2 time. It will be 800 minus Y. It will be 2Y and it will be Y. Okay. So first of all, it is saying that it is increased to 1600 after 10 minutes. So let us suppose this is T1, and T1 is actually our, we'll simply write it, since it is given to us, we'll simply write time 1 is equals to 10 minutes. The initial time given is 10 minutes, and let us take the final time as 30 minutes. It's given in the question itself. So time T2 is equals to 30 minutes. So there are multiple ways of solving this question. I can give you the shortest way possible. But first of all, let us lead the question towards the correct answer, correct outcome. So first of all, let us suppose if we are discussing about this, we can find out the value of K from here. So how you can find out the value of K? So it says that total pressure is increased to 1600. So 1600 will be equals to 800 minus X plus 2X plus X plus 2X plus X. So this will be 800 plus 2X, and this is equals to 1600. That gives X is equals to how much? 400. It will be X equals to 400. So then the pressure of A at T is equals to 10 minutes will be equals to what? 800 minus 400, that is also half of it. That means if this is the half-life given to us, that T half of the reaction is 10 minutes. And using this we can find out the value of K, which is ln2 by K was T half, then ln2 by T half. This is equals to our K. Now using this K value, we can identify the total pressure of the system after 30 minutes. How? Let's see. So at the rate T is equals to 30 minutes, what will happen? There is an equation that we were using, that K is equals to, K was what? ln2 by ln2 by 10 is equals to, let's say we are not taking into logarithm, we will directly take it in ln. So this will become ln of A naught. So A naught is something that you all know, 800 upon 800 minus y, that is what we have to find out, and divided by the time is 30. So we'll solve it, we'll simply solve it. So we can see that ln of 2 raised to the power 3, or we can simply write 3 ln 2 is equals to ln of 800 upon 800 minus y. So this will become 2 to the power 3 is equals to 800 upon 800 minus y. This is actually 8, so this will become 6400 minus 8y is equals to 800, and that's why y comes up as 5600 divided by 8, that is actually 700. So y is 700. If y is 700, then pressure total at the rate time is equals to 30 minutes will be 800 minus y plus 2y plus y. Y will be cancelled, but 800 plus 2 times of 700. So this will be 1500 plus 800, 2300 mm. Hg is the correct answer. So it was an easy question only, but actually some of the calculations were needed here. And if we are pretty much able to make the calculation, then the question becomes even easier. Let me check if the correct answer is 2300. 2200 is the correct answer. So okay. This is 14 plus 2 is 2200 is the correct answer. 2200. Okay, this is coming 22 only. Okay, good, very good. Next, see. Now guys, what the question you are seeing was asked in JEE Advanced 2024. This question came in JEE Advanced 2024. So for this we'll try to do some required calculations and we'll try to find out the answer. Read out the question carefully. This question is for radioactive substances. Definitely it's the first order reaction that it will follow. The question simply says that a sample initially contained uranium-238 isotope of uranium, and with some time the uranium-238 decays to lead-206 while rest of the remains undisintegrated. Okay, so the age of the sample when it is P10 to the power 8 years, then the ratio of mass of this is found to be 7. This is a good question, by the way. Let's read it out. What is it exactly trying to say? So guys, we initially have a sample initially contain uranium-238, and with some time this is actually decaying to lead. So initially let's say we have uranium disintegrating to lead-206. Mass is given actually. So let us suppose initially the time 0 is given, but at t is equals to t, we found that, let us say this is A0 initially, this is 0, this is A0 minus x is equals to AT, and this is actually x. So it is saying that at this age the ratio of lead to the uranium in the sample is found to be 7. So it is saying that x upon A0 minus x is given to us as 7, right? Okay, the mass of lead, that of uranium. No, actually it is mass given to you. Okay. It's a complicated equation, by the way. It's a very complicated equation we'll be getting. So we are not supposed to deal in the terms of mass. This is actually okay. So guys, we know that for x multiplied by 206 divided by A naught minus X, or AT multiplied by the mass of uranium is 238. This ratio is given to us as 7. This ratio is given to us as 7. Or we can do one more thing. I can simplify. This is T is equals to 0. This is T is equals to T time. I found that whatever the mass of lead is there, it is 7 times the mass of uranium left upon. Okay, is it saying with the time, some of the uranium decays into this, and rest of the remain indefinite. With the age of this is this. Mass of lead is that of uranium, and the sample is 7. So let's say this has a mass of 7 m, and this will be having a mass of 1 m. Correct? These are masses. So masses, this divided by 206 will become the number of moles. This will be divided by 206 will become the number of moles. Okay, very simply. So what next is gonna be do? What actually some of the portion, this is actually 80, right? This is 80. This is exactly equals to X. This is 80 and this is X. So 80 plus X will be the A naught. So M by 206 plus 7m by, nahi yaar, this is not 206, this is 238. This is m by 238 and 7m by 206. This is the initial mass given here. This is the initial, not just mass, this is actually number of moles. Okay, this is the moles. So this is the initial number of moles actually, out of which this has been done. Okay, it's fine. And then initially it was 0. So now you can check out, guys, everything is given to us, and now we can use this information and we can find out the value of time. So how time has been divided, how time has to be found out. The formula is simple said that P into 10 to the power 8 years for a first order reaction will be equals to, that funda will be used 2.303 by K. So how do you identify the value of K? Okay, we can identify using this value 0.693 by T half. By T half. How much is T half given? 4.5 10 to the power 9 years. 4.5 10 to the power 9 years. This value into logarithm of A naught by A. A naught is what? 7. Like the mm will be cancelled out. 1 upon 238 plus 7 by 206 divided by 7 by 206. No, 80. 80 is how much? 1 by 238. So guys, this is the expression that you have to use, and you have to identify the value of P. I remember this question was not so easy question, to be very honest. This question literally required some calculations, and then using that calculation you can identify the correct value. So P was actually asked, and P you can identify using this equation. So I remember some 147 or 43. This is kind of 147. Shruti Saurabh is writing. So around that only the answer came. Well, now till here, after this completion of around 1 hour, we all have reached to the completion of integrated rate laws. Integrated rate laws, some applications were used, some basic formulas have to be learned for zero order, first order, second order, and also for nth order. You just need to take the idea how the concentration integrated part has been written. Now, right after that, we have come to the factors affecting the rate of reaction, and these are the factors which affect the rate of reaction. This is what we have to discuss about. So the factors which affect is the nature of reactant and product, temperature, catalyst, blah 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 blah. I'll discuss each and every one by one over here from here itself. Okay, thank you Ankit, by the way. So now let's come to the nature of reactant and product. You know what happens usually whenever the reactions occur? Sometimes solid reactions take place slow. In gaseous phase, the reactions takes place very easily. So every reaction works like this. They all go to the transition state or activated complex. then they reach to the product. So let us suppose we have three things with us: solid, liquid and gas. All of them will be working like this. The potential energy versus time graph is given to all of you. These are the reactant, but this is reactant as reactant in solid state, reactant in liquid state and reactant in gaseous state. So we can see that gaseous state already has a potential energy closer to the transition state rather than comparing it for the solid state. Solid state has a very higher gap of the energies, and it would take more amount of energy for solid particles to be converted into transition state and then leading towards the product. So that's why you can simply say that the rate of reaction will be higher for reactants which are present in gases, then reactant present which in liquid, and then reactant present in solid. That's how it works. So this is the first point meant to say. Very simply, we all have done. Second thing is the surface area. You guys have even seen it. It's all about the rate of reaction, but it can be generalized in our daily to daily examples. You might have seen that a bigger cube of the sugar doesn't dissolve very easily, but a fine powdered sugar which has higher surface area will be dissolved very easily, because with the breakage of a bigger cube into smaller cubes, the surface area increases. Okay, even you can take this example. Whenever a cube like this has been given to you, Arey yaar, I don't know how to make a cube yaar. Where are the options? If we cut it like this, then what does it give you? So this is the extra surface area you are getting. This is the and if you keep on doing the same exercise, you will be keep on getting the extra surfaces like this. Correct. Initially, let us say this is a reactant. Reactant molecules are allowed to be reacting or working upon these sites only. Once this is broken down, these two are the number of sites available. So you always see that fine powdered charcoal does a faster reaction, okay, any reductive reaction, rather than the solid coal particle. So that's how it works. That is the meaning of second point. And the third point is simple, that chemical reaction, chemical nature of the reactant also takes place. So whenever there is required for higher number of bonds are there to be broken, then the rate of reaction will be slower, and wherever there is a lesser number of bonds which are required to break down, lesser amount of energy is required, faster will be the rate of reaction. Like that it works. Then we have the next factor called as dielectric constant. So guys, this is not a very I must say not so important, but yes, just take an idea that let's suppose there is an ionic reaction taking place in water. Now water, why is water called as the universal solvent? Because water has higher dielectric constant. Higher is dielectric constant, higher is its tendency to keep the oppositely charged ions separated, and higher is the separation between the charge, they will more tend to react to the other species present. Otherwise what will happen, they will be attracted to each other. Water will not be able to, let's say another solvent will not be able to keep them separated. No chemical reaction will work until then. So that's why higher dielectric constant leads higher rate of reactions in the medium. So it is defined for the medium actually. Greater is the dielectric constant, greater is the rate of reaction. Then comes the effect of pressure. So the effect of pressure is actually pressure and volume can be seen in Le Chatelier principle. You might have seen it in the chemical equilibrium. Whenever the reactions are under gaseous state, then only the effect of pressure works there. A pressure increase in pressure or decrease in pressure may lead you towards going in either of the direction based upon the Le Chatelier principle. And then effect of light and radiation is only applicable for the photoelectric reaction, photochemical reactions. Higher is the light, higher is the number of photons coming per second, and higher is the rate of reaction, just like that. And then effect of dielectrical magnetic field. This is only applicable to those molecules which molecules are either polar or having the magnetic influence, then only they will be affected, their rate of reaction will be affected by electric and magnetic field. That's it, nothing more than that. Now the effect of temperature, and very important part of this chapter I'm going to reveal, and believe me or not, a question will definitely come in your second attempt of same year. This is the formula that I want to tell you, that rate 2 upon rate 1 will be equals to change in temperature. Now what is it saying? 2 to 3 times, so 2 times of the delta T by 10. Now you will be seeing what have I done. So what I'm trying to say, that every time we increase the temperature by 10 degrees Celsius, the rate of the reaction gets double or triple. So let us suppose this is called as the temperature gradient. 2 or 3 is called as the temperature gradient. So let us suppose in a question the temperature gradient is given to you as 2. That means K, after every increment in the 10 degree, the rate of reaction will be doubled. So what will be the final rate of reaction? If we have made a change of like delta T degree Celsius, delta T could be 40 degree, 30 degree, 50 degree, in the terms of 10 only we have made the changes. So that delta T upon 10 is the number of times that I have to double the reaction, and it is all to the power of 2. This is how the expression is written here. Please read it out. This is an important part of the chapter, I'm telling you. And now we'll take you to the question. Now let's see this question. How is it used? In a zero order reaction, let it be any kind of order, guys. We have to only figure out that how many number of like changes have been done, and the rate of the reaction has been doubled. So doubled as in the temperature gradient is 2. So we'll simply write that, sir, R2 will be equals to R1 into 2 to the power delta T by 10. So this will be equals to 2 to the power delta T is what? 100 minus 10 divided by 2. So this is like 2 to the power 90 by 10 is 9. 2 to the power 9 you have to find out. So I think this will come up as 512 times. The correct answer is B. Akhiyan teri मेरे दिल पे वार करे तुझे ना पता जानिए. All clear till here, guys? Nobody has any kind of doubt? Even if you face any doubt, do let me know. We'll figure out, and I'll try to resolve the doubt immediately as soon as possible. Next is Arrhenius equation. Next comes this Arrhenius equation, okay? So what is the Arrhenius equation? What Arrhenius equation has to say, that the fraction of the molecules which are crossing the energy barrier is this. Anyways, I can directly explain to you guys. There is an equation called as K rate constant is equals to A pre-exponential factor. The rate constant and this A and K have the same values raised to the power EA by RT. EA is called as the activation energy, R is the universal gas constant, T is the temperature, and E is exponent, and EA is activation energy, and K is rate constant, A is the pre-exponential factor. Everything is given over here. Now use this data, that what is exactly this thing tells us. So this is written over here, that this is the number. It's a fraction of the molecule that has an energy more than the energy required, more than the energy which is minimally required, and that energy is called as threshold energy. So the number of energy, threshold energy, or we can say the one which is having the activation energy also, okay? Activation near or beyond activation energy, we can say. So I can also explain this part using a graphical interpretation. So let's suppose that the reaction is an endothermic reaction, because if you find out the potential energy of product which is more than that of reactant, this is product, this is reactant. So which one is having higher energy? Product. That means this reaction is endothermic reaction. So the differences between their levels of energy, so this is one and this is the one, their difference of the energy is called as the delta H of reaction, or called as the enthalpy of reaction. Got it? So what is that term what we are right now talking about? So sir, from here if we go and because everything has to reach there, So this amount of energy is actually called as the activation energy. And similarly, if I assume the same energy from 0, if you have to calculate it from 0 itself to there, this has become the threshold energy. Threshold energy. Like that it works. There's a difference between the activation energy, threshold energy, enthalpy of reaction. So enthalpy of reaction can be identified in two ways. This enthalpy of reaction is equals to potential energy of product minus potential energy of reactant. So endothermic and exothermic can be defined by the magnitude of the value. If it is positive, then it is called as the endothermic reaction. For an exothermic reaction, the magnitude will come up as negative. So this is given to you Arrhenius equation. Some basic parameters are given, but I would rather suggest you that do not undergo unnecessary of the confusion in your mind. Just simply follow this equation, what I have told you, and just move forward. And let's have a question then. Okay. There is one more thing I want to explain it. That if I take logarithm in both of the side, then it will become ln of k is equals to ln of a minus Ea by RT. That's one expression. And if you want to identify the logarithm, then it will become logarithm of k is equals to logarithm of a minus Ea upon 2.303 RT. Why is it so? Because the ln of k can be written as 2.303 log k. 2.303 will go in the division. It will be cut from here, will come at the denominator part. Let's have a question asked in JEE Main 2022. This question was asked. What does this question say? Rate constant K of a reaction is measured at different temperatures, and at the data plotted over here, then the activation energy of the reaction in kilojoule per mole will be what? So guys, you remember that thing? What, sir? The expression that ln of K is equals to ln of A minus Ea by RT. So this is your ln K. So this is a y is equals to c minus mx graph is here, and the slope is actually already known to us, right? So because since it's a straight line, the slope is constant. So guys, the slope is exactly equals to negative of Ea by r. Ea by r, not Ea by r. If I mark it 10 to the power 3 upon t, this is t into 10 to the power 3 upon 10 to the power 3. So 10 to the power 3. So this is actually slope, what we are right now. So this is actually the slope. So slope is equals to negative of Ea by r into 10 to the power 3 is equals to, the slope is actually equals to negative of tangent of theta. So tan theta, how we are going to take tan theta? Like that we have to take, this is the theta. So tan theta will be how much? Even for this you can find out, let's say this is the theta. So tan theta negative tan theta will be base, sorry, even I forgot it. So perpendicular upon base. So perpendicular is 10 by, this is 5, this is 2 actually. So this is Ea upon r into 10 to the power 3. So Ea becomes equals to 2r into 10 to the power 3 joules. So in kilojoule it will become 2r only. I think C is the correct answer. C is correct. Then comes the final part of this chapter called as collision theory. Okay, the final part of this chapter is collision theory. Right after finishing the collision theory, we'll take a break and then we'll start our next chapter called as solutions. Okay, until unless just have a focus on this ongoing topic. We have next topic called as collision theory. Collision theory was given by William Lewis in 1916-18. I don't know it's important or not, but the more important part is the expression that we write over here is this, and you all must know what does this every term mean. First of all, e to the power EA by RT is that fraction of molecule which has energy more than activation energy or equals to it. ZAV is called as the collision frequency, the number of collisions happening per unit time per unit volume there. P is the probability factor. So basically this theory explains that if some reaction has to happen, two reactant molecule must collide in a proper orientation. If they are not colliding in a proper orientation, the reaction won't work. First thing. Number two, that's why the P is the factor has been added. P means they are colliding in the correct positions. Correct positions they are colliding, and that's why the successful collisions are taking place into the products. Okay, reactant to product. Z requires how many number of collisions are taking places. How many number of collisions multiplied by P gives you the overall that successful number of collisions which is going to produce you the product from reactant. Okay. And this part e to the power minus EA by RT exactly represents the fraction of the molecules which are having energy barrier over EA or equals to it, which is required by a reactant molecule to have that minimum energy in order to give you the product. So that's why it has become an expression, and so many questions have been asked. We'll try solving some more question and then we'll see how comfortable we are on this topic. The question simply says, for a given reaction, a large fraction of molecule have energy more than the threshold energy, and still the rate of reaction is very slow. So there is a large number of molecules with higher energy than threshold energy. Then what could be the parameter which is not leading them to convert into product? Definitely the wrong orientations. The wrong orientation will lead you towards the slower rate of reaction, and that's why the colliding molecule will be size no. The colliding must not be properly oriented, correct, and the rate of reaction could be independent. Bakwas baat. One of the reactant could be bakwas baat. I think B is the correct answer. Next chapter has started. Before that, we'll take a small break and then we'll connect back. I hope you all will not go anywhere, or if you want to go, you may take a break and then please come back on time. Okay, please come back on time. Okay. So like the session. So guys, I'm back, and now let's start the remaining part of this ongoing session, which is your complete solution chapter. Solution chapter itself is a smaller chapter comparatively. So like we have electrochemistry is a huge chapter, we have chemical kinetics, some like moderate chapter, but this is an, what should I say, it's an easy chapter also, and there are some lesser number of concepts involved in it. So we'll start one by one, we'll cover them, and we'll start solving some questions also. Number one thing that we have to know is the topic part. So what we are gonna to discuss in this chapter, we'll quickly revise the whole chapter, we'll solve some questions. First of all, what type of solutions are there, methods of expressing the concentration term, molarity, molality on, solubility, then vapor pressure, Raoult's law, ideal non-ideal solution, colligative properties, these are the colligative properties, and finally want of factor. This is the complete roadmap of this chapter. I'll go one by one and we'll try to solve all the things for you. So guys, be patient and stay tuned, and let's start it from the type of solution. So whenever we categorize anything, there could be a number of ways to categorize something. Like you remember when we used to go to the school and we were all divided into different houses based upon that we were worn the jersey or the t-shirt. So like mine was Gandhi house, I used to wear a purple color t-shirt. Someone was the SN house, Subhash Chandra Bose house, and they used to wear yellow color t-shirt. So that's how we were all divided. So that was one of the way of classification. On the same way, a solution is what? A homogeneous mixture of two or more substances is also divided under these categories. Number one is called as physical state. So let us suppose whatever the physical state is of solvent. Solvent is something that is used to dissolve, and solute is something that gets dissolved. Okay, usually they are compared in terms of higher is the amount of solvent, lower is the amount of solute, like that they are treated with. There we have it. So based on the physical state we have, based upon the physical states we have, whatever the nature of solvent is there, the same will be the physical state of solution also. Liquid, liquid, gas, gas. So if solid is dissolved in solid, they will form alloys. Solid, if liquid is dissolved in solid, then amalgam, like sodium amalgam, has a physical state of solid, but it has liquid dissolved in it, which is liquid mercury. And then we have solid and gas. Gas is dissolved in solid, like hydrogen sometimes get absorbed of the surface of platinum. Then we have liquid in sugar, liquid gas. I think this is all manageable, guys. Always remember that two gases can never form a colloidal solution. They will always form a typical solution, or we can call it true solution, or that's the solution we are to a homogeneous mixture. Then there could be another type, like based upon the nature of solvent. Let us suppose the nature of solvent is water, and the water is the solvent used there. We will be calling it as an aqueous solution. If any other solvent other than water is used, we call it non-aqueous solution, like that. If let's say ammonium is used, we call it ammoniated solution, like that. Then we have the amount of the solute present. If more amount of solute can be dissolved, it is called as unsaturated solution. If maximum amount of has been used, you are not able to mix or add any more, you are not able to dissolve any more solute, this kind of solution is called as a saturated solution. And if even on higher temperature we mix or we dissolve more number of solute particles, then its saturated state, this kind of solution is called as supersaturated. So whenever you come back to the normal temperature, the extra dissolved, this solution will become now saturated, the extra dissolved amount will get precipitated out. It's another very important formulation that we use in the separation techniques in crystallization, called as crystallization. Third is on the basis of the solvent additive. If solvent is too much, it is dilute solution. It is in lesser quantity, high concentration of solute is there, called as concentrated solution. And no as such we can say no data is there, they are all comparable. So one is having 4 teaspoons of sugar in 100 ml water. One is having 5 teaspoons of sugar in water. The 5 one will become concentrated, this one become dilute. So these are relevant term, related term to each other. Then we have based upon the concentration of the solute in 2 solutions. So let us suppose 2 solutions have same concentration, they are said to be isotonic solution. One with the higher concentration is called as hypertonic solution. The one with lower will be called as hypotonic solution. That's it. Next term is concentration. So actually I haven't seen so many questions from the classification or the categorizing of this solutions, but mainly the question come from the either concentration part, and not even on concentration, because concentration is already covered in the mole concept. The majority of the questions from this chapter come from the colligative property. So we'll come to the colligative property. We'll also come to the Raoult's law, from which the question come, and Henry's law. So many questions have come, and we'll discuss those questions as well. So before doing that, let's have a focus on the concentration. So what is concentration? How much amount of solute by mass, volume, or the number of moles we have added in the solution is called as the concentration. So concentration could be of percentage mass by mass, percentage mass by volume, percentage volume by volume, parts per million, parts per billion. Okay, this is million, then it should be parts per billion, B. Solubility in terms of gram per ml, percentage gram per, okay, so and then in terms of percentage gram per ml, the volume of solvent is used, volume of solute is used. So this is some formula of concentration that we already have known, and this is something that we study in mole concept also, so it's pretty normal to us. I don't think anything is there which is doubtful over here, and if it is there, do let me know in the comment section, I'll explain. Then some of the most important terms, we come to molality, molarity, normality. This is the more important part. So what is the molality? Molarity is actually the number of moles of solute in 1 liter solution. So this is nothing but the number of moles of solute, volume of solution in liter. If it is not in liter, in milliliter, we have to divide it by 1000. 1000 will go above, and this becomes volume of solution in ml, and this will be going 1000 simply. Then unit is also very much known. The unit is, we say it capital M, that stands for mole liter inverse. Talking about molality, we have a number of moles of solute divided by mass of solvent. Do not take the mass of solution, you got to take it for solvent, and that too in kg, kilogram. So that the unit will become what? Unit will be small m, that means mole kg inverse, per kg. Then comes number of okay, and then comes normality. So maybe it's not mentioned here, we'll do it. Okay, so there were two things that one of them is called as the law of dilution, we use in terms of molarity. It's very simple. Dilution says that whenever we mix water in it, the number of moles of solute will be the same. That's why number of moles of solute will be M1V1 will be equals to M2V2. This is called as law of dilution. The another one is called as the law of mixing. So whenever two substances, two solutions are mixed, in which the number of moles of solute will be added. So how do we define it? We simply say that, sir, M final V final is equals to M1V1 plus M2V2. Like that we do, and V final is also equals to V1 plus V2. Let's see, let's try solving some questions on the same ongoing topic. And before that, we also have normality. So normality is simply calculated as the number of gram equivalents upon the volume of solution in liter. This can also be written down as the molarity multiplied by n factor. It's that simple. Molarity must be known, and that you multiply by the n factor. N factor is something that we already have come across. If not, then meanwhile of the question or somewhere in the middle of concept, I'll explain. But it's a part of redox reactions actually, where we study in detail about n factor. So let's go. We'll directly come to the question first. Okay, the questions which come in the examination are like this. One of the questions that came in JEE Main 2019. So guys, the question might look you a bit difficult, but believe me, these all are very easy questions. If you know the concept properly, you can apply them and you can get the value whatever it is required. Saying that 8 gram of sodium hydroxide dissolved in 18 gram water. So mole fraction, it's very simple. So mole fraction of what NaOH has to found out will be number of moles of NaOH. 8 divided by its molar mass is 40 divided by 8 by 40 plus 18 gram by 80, right? Moles of individual upon upon sum of all the number of moles present in the solution. So अरे यार कहाँ फंस गया वायर? This is 1 by 5, 1 by 5 plus 1, 0.2 upon 0.2 plus 1. This is actually 2 by 12, 1 by 6. So if it is 1 by 6, then correct answer will be 0.167, right? 0.167 is the correct answer. Next is, it is asking us about the molality. So now how do we calculate the molality? We already know the number of moles here. Number of moles are, sir, 8 by 40. So that divided by mass of the solvent. Solvent is what? 18 gram and into 1000. So that's what we have to find out. So this will become, this is 40. So 8 by 40 into 1000 by 18. So this is 25. So 25 200 बट्टे 18, 100 by 9, I guess 1.11 है ना, मोल पर kg, मोल kg inverse. So correct answer should be 0.67, 167 and 11.11. Check out the correct answer. Absolutely correct. D option is correct, right? Now next is 4.5 gram of a compound A with molecular mass of 90 was used to make 250 gram of its aqua solution. Then the molarity of the solution is this. Then value of X will be what? I guess this is the easiest question till now we have faced, which came in JEE Main 2021, exactly 3 or 4 years back. Anyways, the solution will be, we have been given up with the mass of the substance, volume has been given to us, molarity has to found out. So molarity formula is a number of moles, which is given mass upon molar mass into 1000 by volume of the solution given. 250, this will be cut down at 4, and this is 2 actually. So this is 1 by 20 into 4, it is 1 by 5. I think 0.2 molar is the correct answer. 0.2 molar can be written down as 2 into 10 to the power minus 1. The correct answer should be B. Yeah guys, so that's how this question was done, and I found it very easy question here. Another simple question from JEE Main 2021. Sodium nitrate weighed out to make 50 ml of a solution containing 70 milligram of sodium per ml is what? So actually we got to find out the mass of sodium here, and we already have been given with the volume of the solution. Arey yaar, I think this is another very not so much required question. This NaNO3 weighed out to make 50 ml of solution, 60 milligram per ml. So 1 ml has 70 10 to the power minus 3 gram of sodium. So 50 ml of it will be having how much? 70 into 10 to the power minus 3 into 50. So this will be like 3.5 gram just sodium, right? This is 3.5 gram of sodium. So you all know that number of moles of sodium and number of moles of sodium nitrate will be the same. We call it the law of conservation of law of अरे क्या बोलते थे यार, law of principle of atom conservation, है ना, principle of atom conservation. So what we will see that number of moles of sodium nitrate will be 3.5 divided by 23 is the mass of sodium. So using this data we can also identify the mass of sodium nitrate is equals to number of moles of sodium nitrate into molar mass of sodium nitrate. First you identify the molar mass. Okay, so molar mass of sodium nitrate will be 23 plus nitrogen is 14 mass and 48. So how much does it come? 8 4 12 3 15 1 4 5 2 7 और 1 8 85 gram per mole. So simply apply 3.5 upon 23 into 85. Now find out the correct answer. So this is around I think 13 is the correct answer, no? So this will be nearly come up as 13 is the correct answer. 13 grams. 13 gram is the amount of sodium nitrate that has to be dissolved in the solution to make 70 milligram sodium ion per ml. Okay, it's that simple. Oops. So let's move forward to the next question from here. Solution of sodium sulfate that contains 92 gram. Okay, I think this is the similar question, so I would expect you people to try it by your own, or even if you want I can solve it, not a problem, not a big deal. Solution of sodium sulfate contains 92 gram of Na positive ions per kilogram of water. Then the molality of the solution will be what? So what I'll do, we already have how much sodium is there. So simply we'll find out the molality as the number of moles of sodium, which is 92 divided by 23 is the molar mass into 1000 upon the mass of the solvent. How much mass of the solvent is there per gram per kilogram? That means 1000 gram. This is one only, and this is I think 4 gram, 4 mole per kg is the correct answer. 4 mole per kg, 4 is the correct answer, B. See how easy questions have been asked in JEE Main. So the correct answer will be B. So let's take the question to JEE Main 2022. We have commercially sold concentrated HCl is 35% HCl by mass, and if the density of the commercial acid is 1.46 gram per ml, then the molarity of the solution is what? Let's see. So commercially sold concentrated. Okay, I think we'll discuss this tomorrow in our doubt discussion session or in the practice session tomorrow. Until then, you better try it by your own, because these are similar questions. There's no point of solving all the questions by me. It's your exam. You focus on the question, how to attempt it. You do it. Once you read it, you do it by your own. Answer is already given to you and you can apply your own mind. Right after this topic that we have finished, that was concentration, we have another important topic called as solubility, and which is defined as that maximum amount of solute that can be dissolved in a given amount of solution, called as the solubility. But solubility can also be dependent upon what nature of solute and solvent are, then temperature and pressure. So all of these factors affect the solubility. Especially out of these all concepts of solubility, we majorly discuss about liquid solutions, and in liquid solution we can add solid as solute, liquid as solute, gases as solute. Most importantly, gases as solute we discuss, and there is an important concept called as Henry's law that also comes under this part only. So now I'll take you directly to the solubility of a gas in a liquid. So usually all the gases are partially soluble in the water, but their solubility decreases on increasing the temperature and increases on increasing the pressure, and nature also affects it, like dissolve, like ammonia being a polar molecule, and ammonia can easily can do the hydrogen bonding with water molecules, will be easily dissolved in water. Then the gas which cannot make hydrogen bonding with water, like oxygen or like carbon dioxide, or carbon dioxide can get dissolved easily because of the polar nature of the bonds. But anyways, let's say helium you want to dissolve, helium won't get dissolved very easily. So that what is nature of the solute and solvent. Then comes Henry's law. What is Henry's law? Henry's law pretty simple. It actually tells us about the effect of pressure on the solubility of gases, solubility of gas in the liquid, or especially we are talking about water. So usually it has been seen, guys, that if we increase the pressure, the solubility increases. Let us say solubility of a gas in liquid is directly proportional to the partial pressure of the gas you are applying. Higher is the pressure you are applying, higher will be the solubility of the gas. The solubility is expressed in terms of mole fraction of the gas, is directly proportional to the pressure of gas. Mole fraction of gas is equals to some proportionality constant called as KH, 1 by KH. KH is called as the Henry's law constant, Henry's constant, and into pressure of gas. That makes the expression this, that partial pressure of a gas is equals to KH multiplied by X. Here KH is the Henry's law constant, higher is the value of Henry's constant, lesser is the solubility. You can check out, if you increase the KH, pressure will be increased or X will be decreased, like that. So significance pretty simple, that at a particular constant pressure, if pressure has made, partial pressure of gas has made constant, and we are talking about two different gases, and what you will be seeing, that X of gas is inversely proportional to the KH of gas. Then KH values for both nitrogen and oxygen increases with increase in temperature, indicating that the solubility of gas decreases with increasing the temperature. So you always remember this part, that if we increase the temperature, solubility of a gas in liquid decreases. And that is also, we usually say that whenever we dissolve gases in liquids, the process is an exothermic process, and whenever you increase the temperature, the process goes reversal. That means dissolution decreases. If lesser will be the amount of oxygen dissolved in water on higher temperature, then aquatic species will feel difficulty to survive, and that's what has been said, that aquatic life cannot exist, or it is difficult for aquatic life to survive under hot water. They can survive easily under cold water. Even under ice they can survive for a while, or but still it's not possible under hot conditions. Let's see, one question came in JEE Main 2019. Guys, please try this question by your own. The question came in JEE Main 2019 is, which of the following statement regarding the Henry's law is not correct? So different gases have different KH value at different temperature, or that's the same temperature but at different gases have different nature, which is true. Value of KH increases at the increasing temperature, which is also true, as I told you a bit while just now, a second back. Partial pressure of a gas in vapor phase is proportional to the mole fraction, which is true. That is what the Henry law says that. And higher is the value of KH at the given pressure, higher is the solubility. False. Higher is the value of temperature, higher is the value of pressure. Sorry yaar, what is it saying? Higher is the value of KH at given pressure, lesser will be the solubility. Next question please. Next question is, for the solution of gases WXYZ in water. Henry's law constant are this. Correct plot of the graph will be what? So what do you see, by the way, and partial pressure, if partial pressure increases, partial pressure decreases, the solubility should also decrease. I'm not getting what I'm trying to say anyways, but if you increase the pressure, their solubility increases. So let us suppose the partial pressure is increasing, then the value of mole fraction will also increase. It's that simple. But those who are having higher value of KH will be less soluble. So that's what we have to find out. Where can you see it? So I think these two are incorrect, because if we are increasing the partial pressure, then mole fraction of, okay, sorry, this is mole fraction of water. Okay, incorrect. Mole fraction of water will decrease, mole fraction of the gas will increase. So if gas increases, mole fraction of water will decrease. These are incorrect options. Answer is among these two. Okay, then I'll tell you. So WXYZ, the one which is having higher value of KH, will be having lesser solubility, or we can say will be having a lesser partial pressure, we can say. Okay, for a particular constant value of mole fraction, you will find this. So ZYXW, both of them are same, and I personally think that if we increase the pressure, the mole fraction of water should decrease. I think this is where it will go like this, like that, but this is incorrect basically. I think B should be correct one, because what happens right after this point? After this point, we already know that KH value is higher for W. No, yeah, KH value is higher for X. So X always should have lesser X always should have less solubility, and it will be needed higher partial pressure to be dissolved. No idea on what I'm saying, but A is the correct answer given. Okay, so it's not B, it's just A. Now I'll have to recheck this, what is it being given. For a solution, gases are these. The plot of the given data is what? Okay. Why not this? Why just this? So guys, we can also write it like, let us suppose partial pressure, if we are talking about, is equals to KH into X of gas, which can be written as 1 minus X of water. So it becomes P is equals to KH minus KH of X of water. So the graph is like Y is equals to C minus MX. Now you can identify C minus MX graph. So it's a decreasing graph, no doubt. And higher is the mole fraction, lesser is the value of Y. And also the slope. Slope is actually more important right now. Slope over here is negative of KH, and the highest slope is of W. Highest slope is of Z. So yeah, you can see the slope. If I'm talking about slope, that is also negative of KH, is actually higher for Z, has most TP, then Y, then X, then W, and this is what it is followed over here, not over here. Why? Because here, if we talk about the slopey part, you will find that KH, the negative of KH, slope or negative of KH, it's showing me like W has the highest, then X, then Y, and somewhat like that, but anyways this is correct. And then let's move forward here. Now we have the important term called as vapor pressure. Very important part of this chapter. Quite an easy topic, but we have to understand the fundamentals of vapor pressure. So guys, always understand this thing in this way. Whenever a closed vessel is given to you, filled with any liquid, the surface particle which are very lessly bound, because the central one particle is surrounded by all other molecules, but the surface one are bounded in one direction. So they acquire the energy and they start vaporizing. They start leaving the surface like this. Once they start leaving the surface like this process is called as evaporation. They go up and they strike down and then come back like this. The process of coming back is called as condensation. This is called as condensation. So this is evaporation versus condensation. So guys, as a time what happens, because it's a closed container, a state of equilibrium will reach. That's the most stable state. So the moment it reaches to R is equals to evaporation is equals to rate of condensation, at that whatever the pressure of vapor you are exerting is called as the vapor pressure. So you apply a pressure gauge there, try to identify the amount of pressure of the vapors on the surface of the liquid. This amount of pressure is called as the vapor pressure. And what does it depend upon? Nature of the liquid first of all, because if the liquid has higher bonding between the molecules of the liquid itself, then it will be producing lesser amount of vapors. Its vapor pressure will be lesser in that case. But if the liquid has no as such interaction between the two water molecule or lesser extent of the interaction between two liquid molecules, then higher amount of vapor will be produced, higher will be the vapor pressure. And that's why we say that alcohols or like acetone doesn't have too much of the bonding between the molecules. It's just a dipole-dipole interaction. And in water it's an extensive hydrogen bonding. So water has less amount of vapors than the acetone. If sometimes acetone falls off on our skin, it immediately gets evaporated. And because of its evaporation, our body feels cooling sensation. Because evaporation causes cooling. Evaporation requires absorption of the energy from the surrounding. And here in this scenario, when any liquid falls on our skin, the surrounding is our body. Body gives it some energy. That energy is utilized to make this liquid molecules into gaseous state. They go to the gaseous state in the form of vapor. Our body feels the lesser in the temperature, and that is cooling sensation. So anyways, that's the part, that nature of liquid, purity of the liquid, temperature. As the temperature increases, vapor pressure increases. And Clausius-Clapeyron equation explains this part. And then effect of the adding solute. So if we add solute in a liquid, its vapor pressure decreases. If it's a non-volatile solute, if it doesn't impart in the creation of the vapor, then it will definitely fall down. The vapor pressure will fall down. And that is what it has been explained by the Raoult's law. So Raoult's law simply says that if you already are having a liquid, pure liquid, it will be having highest vapor pressure with it, highest possible vapor pressure for it. You add some salt, you add some non-electrolyte, you add some non-volatile electrolyte in it, it will get dissolved. And some of the surface area will be occupied by solute molecules now. Earlier, who was there? Only solvent, who were acquiring energy from the surrounding and getting evaporated. Now, some of the area is already being occupied by the solute molecule. So now, the remaining one for the solvent molecule will go and evaporate. So lesser, basically, number of molecules will be going for evaporation. Thus, the vapor pressure decreases. It's that simple. So, according to Raoult's mathematical expression, the pressure, vapor pressure of the solution is directly proportional to the mole fraction of solvent only, because solute is non-volatile, doesn't create any what vapors here. So it can also be written down as pressure of solution is equal to the proportionality constant will be, let's say K is the proportionality constant. You will write it K into X of solvent, and if X of solvent is 1, that means pure solvent is there. Then this P solution becomes the P naught. So this will become what? P naught P naught of the solution multiplied by mole fraction of the solvent. So this is written down as P solution is equals to P naught into X of solvent. Got it? This is what Raoult's law for vapor pressure of a solution is. But what if we mix two liquids? We are mixing two individual liquids which will be having their own individual vapor pressure. Then the solution will be having P total will be Pa plus Pb. Two liquids are there, two vapors will be there, two type of vapor will be there because of A and because of B. A can be defined as P naught A into X of A. B can be defined as P naught B into X of B. This is Raoult's and this is your P total. So this is very important equation that I am highlighting. And apart from this equation, there is one more important equation, that if I put this XA is equals to 1 minus XB, then an equation on solving it will come up as P naught A plus X of B P naught B minus P naught A, or if I substitute X of B is equals to 1 minus X of A, then it will become P total is equals to P naught B plus XA into P naught A minus P naught B. So these both formulas can be used, but I find this is the most important formula because these two can be derived using from this equation only. This is the most important part of this entire mathematical formula of Raoult's. Next comes is, so that was the mathematical expression, we already have done it. Graphical equation, if you want to see graphical equation, guys, so individual two graphs can be plotted and then they are added up. Let me explain the graphs first of all. So let's say this is a graph for XA and this is like for A we are talking about, this is PA. So here X of A is, let's say, 100%, 1, and B is how much? 0. So some point will be there. This is called as P naught A. Then we have another member here where XB is equals to 1, XA becomes 0, and there is a, let's say this is A is more volatile, that means A has more vapor pressure in pure state than B. This is for this is actually for PB. This was for PA. So the graph will come up somewhat like this. For this it will come up like this. What is the meaning of this? Because if we basically we are decreasing the if you are decreasing the mole fraction of pure solvent, let's say we are talking about A, so it follows the y is equals to C minus mx graph. So this is the decreasing graph. This is again decreasing graph. This is for PB, this is for PA. If you add both of the graphs, it is the graph of P total. Here P total is equals to PA plus PB, that is P naught A XA plus P naught B XB. So this is the graphical interpretation of Raoult's law. For a binary solution means two basically components are there and two separate liquids were mixed together to form a homogeneous solution and both of them were volatile. So composition of the vapor phase, guys, this can also be determined very easily. Okay, so what did Raoult say? What did Raoult say? The Raoult's law says that pressure of A is equals to P naught A into XA, but XA is what? This is in liquid. This is the mole fraction in liquid state. Similarly, there is one more guy. You all know him, John Dalton. His law was Dalton's law of partial pressure. According to him, the partial pressure of A is equals to total partial vapor pressure multiplied by the Y of A. Y. Now Y is what? It is the mole fraction of vapors. This is mole fraction in gas phase or vapor phase. Gas phase oblique vapor phase. Then using these two, what do you get? Just simplify these two, equate these two, then you will be getting that pressure, or you can get YA is equals to P naught A XA by P total, and YB will also be equals to P naught B XB divided by P total. Please guys have a look on this, and then we'll start solving some questions on the same concept. We'll start solving questions on the same concept. हाँ, कहाँ पर है? एक मिनट. Sorry. So let's take back from here. Where were we? This is the vapor phase composition of a solution. Limitations are pretty simple, that it's only applicable for the dilute solutions. It is not applicable to the solutions containing non-volatile solutes. Okay, applicable to the containing non-volatile solute, and it is also not applicable to solute dissociate or associate. There we use Van't-Hoff factor, concept of Van't-Hoff factor. Wherever the solute particle associate or dissociate, there we use the concept of Van't-Hoff factor. Until then, we will be applying the Raoult's law only for no association, no dissociation, simply non-volatile solute added to the solution. That was the maximum of the cases we studied. We have another important question, guys. Let's see this question. There's a vapor pressure versus temperature graph. So vapor pressure versus temperature graph follows this Clapeyron equation, which simply says that vapor pressure is a function of same A e to the power delta H of vaporization by RT. Exactly the similar equation that we studied in the chemical kinetics, like Arrhenius equation. So this is the exponential curve that's follow with the increasing temperature, vapor pressure increases. Okay, if the temperature increases, guys, vapor pressure also increases. The vapor pressure of the solution, vapor pressure of solvent or solution, whatever it is, also increases exponentially. Now let's see the graph. Exponent graphs are there. Temperature increasing and the vapor pressure, as I can see, also increases. So where you can find the intermolecular forces. So always remember that whatever the amount of intermolecular forces are there, if intermolecular forces are higher, then two molecules will not leave each other very easily. A lesser amount of vapor will be created. It's that simple, that intermolecular forces directly proportional to the 1 by vapor pressure. Inversely, okay. So X has higher intermolecular. So let me write the intermolecular forces of attraction. If we have to talk about the intermolecular attractions, then I can simply predict from the graph that at a particular temperature, let's fix a temperature, or for a particular pressure, let's say, higher temperature is needed for Z. Z actually has higher intermolecular attraction than Y, and then comes the X. Y, how can I write it? Because see, X even on low temperature can reach to the higher vapor pressure, but Z requires more temperature. That means in Z there is more attraction between the molecules. If there is more attraction, then definitely there are higher intermolecular attraction. So now correct answer will be X has higher intermolecular, wrong. X has lower, correct, and Z has lower intermolecular, incorrect. So the correct interferences, what do you think, which one are correct? So I think only one is correct. B is correct. Okay, that I was guessing B. Next is another question from here. Let's see the question, guys. A gaseous mixture of two substances A and B under total vapor pressure of this in equilibrium with an ideal solution. The mole fraction of substances A is 0.5 and in vapor phase it is 0.2 in liquid phase, and the vapor pressure of the pure liquid A is 1. I don't know what is this question about. Let me reread it. Gaseous mixture of two substances A and B under total pressure of 0.8. So PT is given to us. What is given to us is P total, which is 0.8 atmosphere. Then equilibrium with an ideal solution. Okay, so A and B are making ideal solution following Raoult's law. The mole fraction of A is 0.5. So in vapor phase, so Y of A is given to us, guys, 0.5. So Y of B will also be 0.5. We also have X of A in liquid phase. It is 0.2. So X of B will be what? 0.8. So the vapor pressure of pure liquid A will be what? So it's very simple. We can apply this formula that Y of A was equals to P naught A XA upon P total. So using that, P naught A can be, P naught A will become what? YA into P total upon XA. So how much is YA? 0.5. Total pressure, vapor pressure is 0.8, or X of A is what? 0.2. So this is 4 times of this. I think 2 ATM is the correct answer. 2 bar or ATM, whatever the unit is given, that is the correct answer. 2 is absolutely correct. A question came in JEE Main 2015. Question is, the vapor pressure of acetone is at 20 degrees Celsius is 185 torr. Torr is mmHg only. 1 mmHg is equals to 1 torr. When 1.2 gram of a non-volatile solution solid was dissolved, then 100 gram of acetone at 20, its vapor pressure was 183. So it has been decreased. Then the molar mass of the substance is. Well, now this question is actually not directly from there, but yeah, it's one of the colligative property. We call it RLVP, relative lowering of vapor pressure, which is equals to the mole fraction of the solute. So what is RLVP? Decrease in the vapor pressure. So 183 and 185, 2 is the relative lowering upon 185 initial. This is called as RLVP, is equals to X of solute will be molar mass, also 1.2 gram of a non-volatile solute. So 1.2 divided by molar mass divided by 1.2 plus molar mass plus acetone is 100 gram upon number of moles of 100 gram upon 60 is the molar mass actually. For acetone, the molar mass is 160. So this is how it look like. You can ignore it and you can simply write it 100 by 60. So it will become what? 2 by 185 is equals to 1.2 by molar mass into 60 by 100. So capital M will be 1.2 into 60 into 185 divided by 200. Now you solve it and you will get your answer. So the answer will be 64. Answer will be 64. Okay. Next topic from solution. So guys, this topic actually the meaning of colligative properties are, there are some specific type of properties for a solution which are dependent upon the number of molecules of the solute or number of molecules of the solvent also, because the molecular number is a fixed number. Let's suppose we are talking about mole fraction, then out of 1 mole of total, how many moles of solute are there, solvent are there. So it is all dependent upon how many number of solute particles are there, rather than what is the chemical behavior of the solute particle, how much is the size of solute particle, what mass the solute particle is possessing. No, instead of those property, it is only dependent upon the number of particles present in the solution, and that's property is called as colligative property. And there are some certain limited number of properties only which are directly dependent upon the number of particles only, not upon the other parameters, and these are 4 colligative properties. Number 1 out of which is called as relative lowering of vapor pressure, RLVP, which can also be written down as delta P by P naught. Delta P is the change in pressure on adding solute. As we all know, according to Raoult's law of vapor pressure, that if we add the non-volatile solute in some solution or some pure liquid, then its vapor pressure decreases. So RLP is delta P by P naught, and it is equals to X of solvent. Okay, there are some more formulas that we can use according to this, but this is the major formula that we use. Then is elevation boiling point, delta TB. Delta TB is equals to KB, which is molar elevation constant multiplied by molality. Delta TF, which is the depression in freezing point, KF multiplied by M. And then last comes the osmotic pressure. Osmotic pressure is pi, which is equals to CRT. Now please guys have a look on these all, and then we'll come forward and discuss each one of them individually. Okay, let's have a look first of all. So what usually happens, let me explain this part to every one of you. So whenever we are with So as I told you that if we are adding a non-volatile solute in the in a liquid which is having a particular vapor pressure, its vapor pressure decreases. Just because its vapor pressure decreases, its boiling point increases, because boiling point is that temperature which is required to reach the vapor pressure of a liquid by external vapor pressure, which is 1 atmosphere. Okay, so external vapor pressure is 1 atmosphere. If something has to reach to 1 atmosphere, 1 atm pressure, what temperature has to be required? That is what we call as the vapor pressure. Now it's a very amazing part over here, that if you want to make the vapor pressure as 1 atm, you have to create more number of vapors to increase the vapor pressure. In order to create the more number of vapors, we have to give it more temperature, because on addition of non-electrolyte or non-volatile solute, the vapor pressure is decreased. So that means more temperature is required, and that more temperature is necessary or responsible for elevation in the boiling point. And the same happens in the freezing point. It's a opposite, we call it depression freezing point, because let us suppose for a solid we have to reach to, let's say, 0 vapor pressure. Let's suppose from the liquid state we have to reach to 0 vapor pressure. At 0 vapor pressure, if we want to reach it, earlier we were coming from higher vapor pressure, decreasing the temperature and decreasing the vapor pressure as well. Now we already have lower vapor pressure, and now we are reaching towards 0. Then it will take even lesser amount of temperature differences. So lesser is the temperature difference. That difference is called as depression in the freezing point. The depression freezing point is also equals to molal freezing constant into molality. M is the molality. And the final one is osmotic pressure, which is CRT, concentration molarity, into R, universal solutions constant or gas constant, is the same value, 8.314 joule Kelvin inverse mole inverse, and T is the temperature. So everything is given to us. Let us use everyone one by one, and let's start solving their questions. JEE Main का result आने वाला है. Yes, you're right. Probably very soon it will come. We have JEE Main 2019 question, everyone with us. 1 gram of a non-volatile electrolyte solute is dissolved in 100 gram of different solvents A and B whose ubuloscopic constants are in 1:5. Then the elevation, this is a most easy question here. So what you will do, you will write delta TB for A, delta TB for B is equals to, so since it's a non-electrolyte, we can see that Van 't Hoff factor I will be taken as 1. So no need to be worry about I, just simply focus on the formula and get the answer. So it's Kb for A into molality upon Kb for B into molality, and same amount of solvents are used now, so that, and the exactly same amount of solute is also used. Molality will be same, so it will be in the same order of ubuloscopic. 1:5 is the correct answer. That's it, 1:5, A to B. Okay, having our next question from JEE Main 2019. The elevation, the boiling point for 1 molar solution of glucose is 2 Kelvin. The depression in the freezing point for 2 molar solution of glucose in the same solvent is 2 Kelvin. Relation between Kb and Kf is what? So actually, we have two things here. Number one is elevation, the boiling point 1 molar solution. So delta TB is equals to I into Kb into molality. I is Van 't Hoff factor, which is not required here. It's a electrolyte solute is used because glucose has always I is equals to 1. It's a non-electrolyte solute. Kb into M. So delta TB is 2 Kelvin. Elevation is 2 Kelvin. This is Kb. Molality is already given 1 molar. Similarly, delta TF, depression freezing point, is Kf multiplied by molality. How much is the depression in the freezing point? 2 Kelvin, and molality is 2, and this is your Kf into 2. So now you divide these two equations. This is 1, this is 2. So if you divide it, we'll see that K freezing upon K boiling. Okay, 2 times of freezing and 1 time of boiling is equals to 2 by 2, 1. So Kb is equals to 2 times of Kf. That's the answer we are getting. Kb equals to 2 times of Kf. Kb equals to 2 times of Kf. I think B is correct. Okay, there is a question now on what we call it. Okay, try this question, guys. You better try this question by your own. Okay, allow me a second. Okay, so let's see this question. What has been asked? A cylinder containing ideal gas is in thermal equilibrium with a large volume of 0.5 mole aqueous solution of ethylene glycol and its freezing point. At its freezing point, if the stopper S1 and S2 shown in the figure are suddenly withdrawn, the volume of the gas in liter after equilibrium is achieved will be what? So this is something. If the stopper S1 and S2 are suddenly withdrawn, Okay. So first of all, we have to know that how much is this value in the thermal equilibrium. Of course, ethylene glycol is there. What vapor pressure is there? No. Let's suppose if I find out the delta TF. So guys, actually what is happening, try to understand. This is an ideal gas and there is an atmospheric pressure. There is an atmospheric pressure and this gas is also applying. Glycol is there, no? And we'll to see actually what is this here. कहता है तेरी गलियों में ये रहता है जानो समझो. Now I have got it a bit question, but we have to like check whether we are in the same direction or not. Okay. Okay, that is good. David Villa, that's a good. So first of all, understand this, that there is an ideal gas entrapped here, and this ideal gas and this ethylene glycol are having the same temperature. First of all, try to understand what is the initial temperature. Okay, so let's see the temperature. So you will apply the formula delta TF is equals to I into KF into molality. We are just putting I here, but I will be 1 for ethylene glycol. Even for alcohol, even for all the non-electrolytes, it will be 1. Delta TF, change in vapor, change in the freezing point or change in the temperature will be, because of this ethylene glycol container, this delta TF will be how much? 1 into KF is being given to us, which is 2. Molality is how much? Molality is 0.5. So delta TF is coming as 1. Delta TF is what? Change in temperature. So temperature of pure water, which is actually how much? 273 Kelvin, 0 degree Celsius, minus the final temperature has been reached. So minus the temperature which it has been reached with addition of ethylene glycol. So this is the temperature of solution, or we can simply say it is T1. So let's say the T1 will be coming up as 272 Kelvin. So that's the first thing that we derived. We have got the temperature now. Cylinder with ideal gas, this temperature is given to us, molarity, so everything is known to us now. with a large volume of 0.5 molar ethylene glycol, freezing point is this. Suddenly it is removed. Then final pressure will become equals to the atmospheric pressure for an ideal gas also. And initial pressure is something that we have to know. So how do you know the initial pressure? Apply PV equals to nRT. So pressure will be nRT by V. So how many number of moles are here? 0.1. What is the value of R? 0.008. You can also take it 1 by 12. And temperature, we got it 272 initially. Upon volume, how much is the volume of this ideal gas? It's given 1 dm cube in 1 liter. So it's more or less like how much is it coming? 24. 22.7, let's say 2.27 liter. Sorry, ATM. This is the pressure actually right now. This is the initial pressure of this gas. This is P1 actually, okay. So temperature is still the same. What happens after removing this? After removing the cork, since temperature is the same only, and we are removing stoppers, so what happens? P1 V1 equals to P2 V2. It's an isothermal process. For an isothermal process, P1 V1 equals to P2 V2. Okay. So you apply and find out the volume of the gas in liter after equilibrium is attached, which is V2. So V2 will be pressure 1. How much is the pressure 1? Sir, 2.27. Volume 1, sir, this is 1 liter divided by final pressure will become 1 atm approximately. So around 2 point, this is correct, around 2.2 what we are getting, or 2.18 is the nearby answer will be there. But this was not an easy question, by the way, because it had too many things involved in it. Okay. That's why like I took some time to figure out what has been asked, because it is more important to know what has been asked rather than getting the answer unnecessarily. David Vilai is saying, sir, why are you taking too much time to understand the question? So David, I'm just a human being, buddy, and David, you have no idea, you unnecessarily are messing with me, but it's okay, let me ignore you. We have sorry, we have next question. The osmotic pressure of a solution NaCl is 0.1 and that of a glucose is 0.2. The osmotic pressure of the solution is formed by mixing 1 liter of the solution. This is actually will be conducted. I'll do it, but unless take it as a homework now, because first of all we need to know about Van 't Hoff factor. First we have to understand the concept of Van 't Hoff factor, then I'll do it. Okay. First you'll understand about the Van 't Hoff factor. So let's understand Van 't Hoff factor first and then we'll come back to this question. Okay. So guys, Van 't Hoff factor, what is Van 't Hoff factor? Sometimes what happens whenever a solute is dissolved in the solution, it sometimes gets dissociated, it sometimes gets associated, due to which the number of molecule changes. And as we all know that the colligative properties are dependent upon the number of particles of solute. So the particles may increase or decrease. So according to that, colligative properties will also change. So how can we define I? I simply defined as, guys, the number of solute particles after association / dissociation divided by the number of solute particles before association / dissociation. It's that. So the final number of particles after associating or dissociating will give you the newer value of colligative property. So we can also say that actual colligative property upon theoretical colligative property, or we can also say, see, that See, colligative property is directly proportional to the number of moles, and number of moles are inversely proportional to the molar mass. So colligative property is inversely proportional to the molar mass. So we can also say that theoretical molar mass upon actual molar mass. That is also one of the way. So normal molar mass upon abnormal molar mass, observed colligative property upon calculated colligative property, or number of particles before and after. So all of these are the methods of expressing Van 't factor I. I'll let you know about one more thing, that we can undergo two situations here. So let us suppose if we are going association somewhere versus we are going dissociation somewhere. So if we go association, the I will definitely be less than 1, and in dissociation I will be greater than 1, because something is dissociated, it will be creating more number of particles. Something is associating, getting connected, will be having lesser number of particles. So I is lesser than 1, I is greater than 1. So for if degree of association is given to you, the formula becomes 1 plus 1 by n minus 1 into alpha. This formula we have to learn, guys, where n is what? N is like n times of AR going to form AN with alpha. Similarly, over here, I will become equals to 1 plus n minus 1 into alpha. What is the value of n here? N could be AN on dissociation with alpha degree of dissociation gives you n times of A. So that's what we have to know. If you know this formula, you can apply it and you will get whatever it has been asked. So let's try one question here. Before going to the question, all the colligative properties now will be changed with I. So wherever you find the number of moles of solute, you got to add I over there, because I is the number of final number of moles which you will be getting. So every colligative property will be multiplied by I wherever the number of moles of solute were included in the terms of concentration, whether terms directly or RLVP, whatever it is. So let's say if we have to find out the RLVP. So RLVP was I multiplied by number of moles of solute, because it is equals to the mole fraction. So I into number of moles of solute, number of moles of solvent. That is a different part, that I into number of moles of solute can be ignored in the comparison with the number of moles of water or solvent, because solvent is always present in higher amount, and mainly when it is a when it is mentioned it's a dilute solution, then in that case number of solute will be neglected in comparison number of moles of solvent. Elevation and boiling point will become I into Kb into M. Depression freezing point will be I into Kf into M. Osmotic pressure will be I into CRT, ICRT. So everything will be now multiplied by I, and that's how we have to figure out. That's it. Okay, now let's see some questions. A question came in JEE Main 2021, few years back. Question is, which of the following molarity is the same? So you know depression freezing point, lowest freezing point will be off. So you know depression in freezing point is directly proportional to I. So the value of I over here is 2 ions will be produced. Here 2 aluminum, 3 sulfate, 5 is there. Here only 1, because it is a non-electrolyte, doesn't dissociate, and this will be 3. Correct answer should be B. See how easy is this question? Van 't factor of a 0.5% W by W solution if KCl freezes at negative 0.2 degree. So see, first of all you apply this equation, that delta TF is equals to 0.24, because you know delta TF is found out like freezing point of pure water minus freezing point of solution. Freezing of water is 0 degrees Celsius minus 0.24 degrees Celsius with a minus sign, comes with positive of 0.24 degrees Celsius. So 0.24 into Kf you have to find out, I guess, into molality. So how do you find the molality? 5 grams, 0.5 grams. So 0.5 divided by KCl. KCl has a molar mass of potassium 39. Molar mass of KCl, let me find out. 39.5 plus 35.5. Or let's say it's 39 only. So it will be 74.5 into 100 divided by into 1000 divided by mass of the solution will be solvent will be nearly 100 gram only. 100 minus 0.5, which is exactly the same. This will come up as 10. 5 by this, so 0.24 into Kf into 5 by 74.5 is equals to delta TF. How much is the delta TF? अरे यार, delta TF is equals to I into this. So 0.24 is equals to I multiplied by this. So I will be coming up as, so ऐसे this is just roughly doing it. देखो, this is 15 into तुम्हारे थे हमारे अरे यार, KF is not given क्या? KF actually is 2. We studied somewhere. So anyways, KF, let's say KF is 2. So 15 into 0.24 divided by 2 is the correct answer. I think C should be the correct answer. C is correct. Okay, I made some rough calculation, but anyways, we got up to the correct answer only. This question came in JEE Advanced 2024. JEE Advanced 2024, very this year, like a previous year of JEE Advanced examination. This question appeared there. Please guys, try this question by your own. A vessel 1 is there which contain W2 gram of non-volatile. Non-volatile means I is 1, X dissolved in W1 gram of water, and blah 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 is there. Both of the vessels at the same temperature pressure. The molar mass of X is how many percentage of Y? 1 to factor X is 1.2 times of this. So everything is given to. The elevation boiling point is this. No idea what is given. The elevation of boiling point is insulation vessel 1 is itna percent of vessel 2. So okay, we'll do one thing. We'll simply write delta TB of vessel 1 upon delta TB of vessel 2 should be equals to. So this will be I for X into KF, KB of X, KB of 1, okay, and water only we are discussing about now. I think KB is the same for water, no? I into KB into delta, sorry, molality. So molality will be mx by IY KB into my. So KB will be first cancelled out. Thankfully, one of the problem is resolved, which is KB. Now rest of them, I of X is given the water factor X is 1.2 times that of Y. So this is actually given to us as 1.2. So we'll write it simply 1.2 into W1 gram of water. Vessel 1 का W2 non-electrolyte. So W2 upon molar mass of X into 1000 by W1 gram of water divided by molality of second Y. It will be vessel 2 contain W2 gram of another non-volatile. So W2 gram of another non-volatile, so dissolved in W1 gram of water. So My, so this is cancelled out. W2 is also cancelled out. This is equals to 1.2 into molar mass of Y by molar mass of X. How much is molar mass of Y and X? So this is W2. And yaar, I got confused. Yaar, what's written here? W1 gram of water is there. W2 gram of X is there. And then we have the molar mass of X is that of Y. Okay, it has been given. %80 of this. So molar mass of X is actually 0.8 times of My. So this is equals to 1.2 by 0.8. We can also write it like 4 by 1.5 is the correct answer. But if it is asking about the percentage, it will 1.5 to 100, 150%. 150% is the correct answer. So probably guys your result is out and the server crash. Okay, or let me check. Our team is working. If it is out, they'll update me. Okay, come here. We have two type of solutions here. One of them is called as ideal solution, another is a non-ideal solution. Based upon ideal and non-ideal, these two are based upon the Raoult's law, whether they follow or not. So ideal solution are the one which follow or which obeys Raoult's law, and non-ideal are the ones which do not obey Raoult's law. So let's see. We have ideal solution. First of all, let's have an ideal solution with us. What is the meaning of ideal solution? Ideal solution is the one that follows Raoult's law. So the solution which obeys Raoult's law over an entire range of the concentration are called as ideal solution. Pa will be P naught XA, P will be P naught B XB, and P total will be PA plus PB is equals to P naught XA plus P naught B XB, like that. They have similar structures, they have similar kind of bonds, they have similar sizes, and that's why these properties like delta H of mixing will be equals to 0, delta volume of mixing or solution will be equals to 0, delta S on mixing, entropy always increases with the in like mixing two solutions. More number of like particles might be same, but more number of space is available for particles to move around. Delta S total will be greater than 0, and delta G of mixing for a spontaneous process, the delta G is always negative. These are the set of properties that will be followed for an ideal solution. Now talking about non-ideal solution. Non-ideal solution can also be defined into two categories: negative deviation, positive deviation. What these two are, let me define. So whenever a solution does not obey Raoult's law, it is called as non-ideal. So Pa is not equals to this, Pb is not equals to this. P total, however, will always be equals to Pa plus Pb, but P total will not be equals to P naught AXA plus P naught B XB. Now this could be even higher than that, called as positive deviation, and if it is lesser than P naught AXA plus P naught B XB, it is called as with the negative deviation. Let's start it from the positive deviation. In positive deviation, even Pa is greater than P naught AXA, Pb is greater than P naught B XB. The graph should not be linear, a bit above to the basically expected one. Above, all graphs are above to the expected ones. The one which is following the Raoult's law will be, our pressure will be a bit higher than that of we are getting from the Raoult's. Then we have, so for these guys, delta H is greater than 0, delta V is greater than 0, and these two will be the same, that delta S of the mixing will always be greater than 0 and delta G of mixing will always be lesser than 0 for a spontaneous process. Examples are very important, guys. Those who do not know how to remember the examples, I give you the most appropriate way. For all the solutions with positive deviation, they will be having higher vapor pressure. They will be having higher vapor pressure than the expected from Raoult's law. So if something is having higher vapor pressure, then definitely these two molecules should have different interactions, so that these two will not attract each other. Vapor pressure will be always higher, and these two molecules in fact repel each other, kind of. So like one is acetone, ethanol. These two are like with different kind of, this has H bonding, this has no H bonding, this is nearly non-polar, this is polar. Water methanol or water ethanol or CCl4 plus toluene or whatever it is there, which are having no linkage for each other, which has no attractional forces between two molecules, these all will come under the category of positive deviation. In the similar way, if you are going towards negative deviation, the one which is in the negative deviation, we have this, the pressure individual P total will always be equals to PA plus PB, but it will be lesser than P naught XA plus P naught B XB. The graphs will also be found in the lower zone. This is the expected Raoult's law, it is a bit lesser than that value. So all graph will be declined like this, okay. Now there should be a proper attractional force between the particles A and B, that was not present in A and BB. So if there is a force of attraction between these particles, these two particles must attract each other, and their nature should be the same. Let's polar attracting polar, like aniline and we have acetone. So aniline and acetone might attract to each other. Acetone chloroform, it's ethanol or ethanoic acid, water HCl. So these two are supposed to react to each other. Whenever two substances are reactive each other, there is a force of attraction between these two, bond between these two, that allows it to have lesser vapors and lesser vapor pressure than it is in the Raoult's. So that's how it works. One more important part is delta H of mixing is less than 0, delta V of mixing is also less than 0, but delta S of mixing will always come up as greater than 0, and delta G of the process will always less than 0 because it's a spontaneous process. Next is azeotropic mixtures. Now what are azeotropic mixture? Okay, so azeotropic mixture is like, first of all let me give an idea how azeotropes are made. We had a Raoult's mixture, we have a non-Raoult's mixture. Let's ideal and non-ideal. Ideal mixtures can never have azeotropic mixtures because there are two individual liquids which are mixed into each other, making a homogeneous solution, and both of them have separate identities of in each and individual, do not behave as a common molecule, okay. But now azeotropic mixtures are one. It actually happens in the case of non-ideal solutions, where either the overall boiling point of solution comes lesser than the individual PA/PB, overall basically boiling point comes lesser, or overall boiling point goes higher. So higher means it becomes with negative deviation because there is attraction to the particle, and if it is lesser than the overall, then there is a high vapor pressure formed, that means lesser force of attraction with the particle, that shows positive deviation. Then anyways, one by one we'll study each and every one and we'll come to the conclusion. It's a mixture of two liquid which boils at a common temperature and cannot be distilled away is called as an azeotropic mixture. Distillation is done on the basis of difference in the boiling point, but since these two are behaving like a common molecule, there is no difference in the boiling point, and thus they are called as azeotropic mixture and cannot be separated using the distillation. There could be two type of thing: minimum boiling, maximum boiling. Minimum boiling happens in positive deviation, and this happens in negative deviation. So minimum boiling azeotrope. What are minimum boiling azeotrope? The one which are having the positive deviation from the Raoult's law. The one which is having positive deviation from Raoult's law will be having lesser force of attraction between the two particles. Their vapor pressure will be high, and thus their boiling point will decrease. Why? Because sir, if some particular solution or the liquid has higher vapor pressure, in order to make this vapor pressure equals to the atmospheric vapor pressure 1 atm, we will require even lesser amount of temperature to be increased, and lesser amount of temperature to be increased means it's a minimum boiling azeotrope. And these kind of things happens at a particular composition only. So I'm giving you few examples. Please learn them and do not unnecessarily fall behind this topic. Just simply stay activated. Not too many questions come from this topic, but still we have to take an idea that, for an example, 95%, 95.5% of ethylene glycol, which is ethanol, and 4.5% water makes this solution called as minimum boiling azeotrope. Next, maximum boiling azeotrope, in which the boiling point of the solution becomes even higher than the individual ones. And why does this happen? Because these two molecules now act as a common molecule. And common molecule, why common molecule? They are behaving like common molecule because there is a force of attraction between these two that makes its boiling point higher than the expected individual ones. The mixture of two liquid boiling point, which is more than the pure components. Boiling point is more than the pure component, and these are formed by non-ideal with negative deviation. Example is acetone and chloroform. Example is acetone and chloroform. Okay, let's try some questions, guys. Let's try some question. The mixture that shows positive deviation from the Raoult's law. So positive deviation, you all know, benzene, toluene, it is ideal. Acetone, chloroform will attract each other, it's a negative. Chloroethane, bromoethane, again ideal. Ethanol, acetone, this is positive. So this is the correct answer, 4. So that's how you have to check it. Okay, in basically positive deviation, molecules might be repelling to each other, and that's why their vapor pressure becomes higher than the individual one. Sorry, higher than the expected Raoult's vapor pressure. Which of the following is not equals to 0 for an ideal solution? Ideal solution doesn't have delta S of mixing as 0. Delta X of mixing is always greater than 0. So guys, please try it by your own. Take your time. I'll come back and join you. Please try this question. Let me check if the result is out or not. I'll come back and join you. So guys, hopefully you done it. Okay. So people are more concerned about the JEE Main result, not attempt 2. Anyways, so we have a question here, 2020 JEE Main 2020. This question came in. The question simply says that vapor pressure of CS2 is 512 mmHg, and that of acetone is also given. The solution of CS2 in acetone has a total vapor pressure of 600. False statement is okay. First of all, you do one thing, try to find out the Raoult's vapor pressure. Okay. No, but how much is the percentages? CS 512 and that of acetone is this. Vapor pressure of CS2 this. A solution of CS2 and acetone has a total vapor pressure of this. Then false statement. So pure basically we have been given with the, let's say P naught A is given to us 512 and P naught of B is 344 mmHg. Our solution of this in acetone has a total vapor pressure of this, but how much we are adding here? The Raoult's law is not obeyed in the system. False statement you have to pick. So anyways, let's take them half. What is the P total as per Raoult's? 512 mole fraction will be 0.5. So into 0.5 plus 344 into 0.5. How much does it give it to you? Half of this. So I think there's a negative deviation we see, right? So if the pressure is coming, Raoult's is coming this much, and a solution of CS2 has a total. So guys, it's a positive basically, and but P total actual is 600 mmHg. Is actually okay. And there is one more thing we can explain. Even if this is 100%, okay, there is one more thing we can do, guys. There is one more thing we can do. Let us suppose this is 100%, okay. You always try to find out P Raoult's, P total Raoult's will always be lesser than 512 mmHg. Because the individual components we talk about, individual component, let's say this is 100%. If CS2 is 100% and this is, let's say, 99.99%, that is 0.01%. In that case, 512 mmHg cannot be, like your Raoult's vapor pressure cannot go beyond 512. But actually, PT actual is coming 6 mmHg, 600 mmHg. That means this is a case of non-ideal solution. So of course this is a non-ideal solution with positive deviation, because it is coming more than the individuals, sum of the individuals. So it is a positive deviation. Since it is a positive deviation, it is not obeying the system, true. And this is false, because 100 ml, something with positive, the volume total must come greater than 200 ml. Delta V is positive. You remember? Delta V is positive for this, but this is false. So I think B is correct answer. B is correct. And that's it, everyone. That's it for the day. Thank you so much, everyone. Please attend my tomorrow's lecture. Tomorrow's lecture will be held on our this is a special session, will be held on our application Unacademy. Please go and enroll. I'll create a link and will be posted in the comment and your description also. Bye bye, everyone. Take care.